Terus sa ano, saan na ba? Yun.
Good afternoon, everyone. Before we get started, let us first offer a prayer for the success of this webinar.
Good day, everyone, and welcome to the second session of our Meet the IAU Astronomer program. This is Justine Castillo.
And I am Gerlie Cortez from the Space Science and Astronomy section of PAGASA.
For the sake of our new participants, let me give you a brief introduction on today's webinar. The Meet the IAU Astronomer is a program offered for free by the International Astronomical Union-Office for Astronomy Outreach, aiming to connect teachers, informal educators, and amateur astronomer groups with IAU-member astronomers through a virtual presentation. This year, we invited IAU astronomers in this series of webinars, starting with Dr. Diana Besliu-Ionescu, who discussed the Sun and its impacts on Earth last July 9. And now, we are on our second guest astronomer. With this being said, we would like to welcome teachers, students, organizations, our colleagues from PAGASA, and other returning participants that are present here today.
Before we get started, we would like to go over a few reminders for everyone to participate actively in today's event. First, as displayed in the slides, we would like to remind everyone to please mute your microphones and turn off your cameras. This is to prevent unwanted noise and unnecessary distractions.
Also, participants will have the opportunity to submit text questions to our presenter by typing the questions in the question box in the Google Meet control panel. You may send in your questions anytime during the presentation. We will collect this and address them during the Q&A session at the end of today's presentation. You will also have the opportunity to ask your questions directly to our presenter. Just raise your hand, state your name and affiliation, and the question once we open the Q&A session.
Lastly, we will be providing a certificate of attendance to those who will stay with us until the end of the program. We will appreciate it if you will give your feedback through the evaluation link that we will be sending after the program.
To formally begin our program, let us hear from Dr. Vicente Malano, Administrator of PAGASA, for his welcome address.
Thank you, Justin and Gertie. A pleasant day to all. I warmly welcome everyone, especially our distinguished resource person, Dr. Salvador J. Ribas from Parc Astronòmic Montsec of Spain, for sparing us his precious time to share his knowledge and expertise. He will be imparting his expertise particularly on the topic of light pollution and its multidisciplinary effects. I am grateful to everyone who are attending this webinar, to our colleagues of PAGASA, teachers, educators, students, officers of the Disaster Risk Reduction Management Office of the different local government unit, members of different astronomy organizations, and everyone here present. PAGASA is honored to host a virtual meeting like this with a renowned astronomer through the Meet the IAU Astronomer program. This is a program offered for free by International Astronomical Union-Office for Astronomy Outreach, or IAU-OAO. Once again, I would like to thank Dr. Salvador Ribas. Muchas gracias, Dr. Salvador Ribas. And I wish you all of this, all for the successful and fruitful program. And lastly, I would like to thank everyone, particularly the Space Science and Astronomy section, led by Miss Chat Ramos, and Research, Development and Training Division, headed by Dr. Nat Servando. Thank you and good day.
Thank you, Dr. Malan. And now for her opening remarks, may we call on Dr. Esperanza Kayanan, PAGASA's Deputy Administrator for Research and Development.
Thank you very much. Justin and Girly? Thank you very much. Dr. Vicente Malano, PAGASA Administrator. Dr. Salvador Ribas, our famed resource speaker for today. Distinguished guests, ladies and gentlemen, a pleasant day to everyone. Last July 2021, PAGASA hosted a virtual meeting with Dr. Diana Besliu UNESCO, a renowned solar physicist from Astronomical Institute of the Romanian Academy, through the IAU Astronomer program, where Dr. Diana discussed the effects of the sun on Earth. And now we are virtually gathered again to meet another IAU astronomer and have a fruitful discussion about light pollution. Light pollution is referred as the presence of artificial and/or anthropogenic light at nighttime, which makes the sky appear brighter than the natural sky. Those who love stargazing will agree with me that light pollution significantly affects astronomy, as it hinders the appearance of faint stars and astronomical objects such as galaxies, nebulae, and others. Actually, this is also a very interesting topic for me, as I was a lecturer on atmospheric physics, wherein we discuss about the atmosphere and the density of the atmosphere, which I believe will be discussed here, that it affects how we see or how we view the stars. So today, Dr. Salvador Ribas will discuss about the multidisciplinary problems produced by light pollution and how the sky quality can be assessed, measured, and evaluated. Dr. Ribas will also tackle several laws and policies implemented for the protected areas in Montsec and Catalonia against light pollution. Hopefully, in the future, the Philippines can adopt these policies to address and manage the rapid sprawl of light pollution, and that it will not further compromise the quality of astronomical observation and other possible impacts it can produce. So let us all sit back, use our imagination as we enjoy the insightful thoughts we will gain from the lecture of Dr. Ribas. Thank you very much and good afternoon.
Thank you, Dr. Kayanan. Now, without further ado, may we call on Ms. Maria Rosario C. Ramos, the IAU National Outreach Coordinator of the Philippines and the officer in charge of the Space Science and Astronomy section, to introduce our speaker for today.
Thank you, Girly. So good afternoon, everyone. Dr. Malano, Dr. Kayanan, Dr. Servando, colleagues, and participants. Our resource person for this afternoon's Meet an IAU Astronomer session is a member of the International Astronomical Union and the manager of Parc Astronòmic Montsec. He is also an associate lecturer at the University of Barcelona in Spain. He obtained his doctorate degree on astrophysics, specializing on the field of light pollution and quality of the night sky. He has been involved in research and outreach programs against light pollution, like European projects Pyrenees La Nuit or Loss of the Night Network. He was a team leader for the certification for Starlight Reserve of Montsec. Currently, he combines a task in Parc Astronòmic with research activities on light pollution and quality of the night sky with a dozen of papers published, with 39 publications and 367 citations. Without much ado, please join me in welcoming our invited IAU astronomer, Dr. Salvador J. Ribas.
Hello, can you hear me?
Yes.
Yes, loud and clear.
Okay. And I hope that you can see my screen with the first slide of my presentation.
Yes.
Perfect. So everything is working. So first of all, let me thank for your beautiful introduction, and thanks for organize these events. I'm, as you said, member of the International Astronomical Union, and I try to help in all the actions that are possible from my location here in Montsec Mountains, and I will be happy to explain a little bit the most important effects of this problem, of light pollution problem, that is very, very linked to our main topic, that is astronomy, but not only astronomy. So, as it was said in the introduction, I'm an astronomer. I am the manager of the astronomical park in Montsec. I will talk a little bit about Montsec, about the protection of this area in the end of my talk. And I'm also an associate lecturer in the University of Barcelona and member of the Spanish Research Network on Light Pollution. These are the REECL that appear on the bottom right on the screen. And this is let's try to start a bit. I will, okay, let's see if it works. Okay, it seems it works. And I will just summarize a little bit what we try to explain today. First of all, we'll start with what is light pollution. Then we will do an overview of the components and some examples of light pollution. And the third stop in our trip will be talking about effects of light pollution. And at the end, in the second main block of our session of today, I will try to summarize how we can measure light pollution with some particularities on our case study in Montsec Mountains. And at the end, we will open the discussion with some slides that I have titled, "What can I do?" What any one of us can do to help to reduce this problem. So let me go ahead and start with what is light pollution. Here we can see 4 images from 4 big cities in our planet, and you can see that there is a lot of light there. And you can see here on the top left, for example, a lot of lights coming out from the offices. Probably there is nobody working there. It is night time. Probably they are not anybody in the office, or just few people. And we have a lot of offices, buildings around the world that are switched on in the wall light. This is for sure a kind of light that is not necessary to use. Or on the top right, we have a lot of billboards. This is a big problem that is now under study for the international community about how to manage this big amount of billboards that are appearing in all the cities. In the past, we have the image of billboards in some in very specific points of some of the cities, of the biggest cities in the world. But now these billboards are appearing all around, also in small cities. So this could be a future problem. Another picture here on the bottom left, this is a river, or when we have well, we are creating a problem with the light that is flowing to the water. So for sure, if there are any species living here, they will be affected by the presence of light at nighttime, because in normal conditions there will be no light on the sea, on the river, or any freshwater area. And here on the right, we see the Eiffel Tower. This is a typical worldwide known landscape, and it's normally very illuminated for any reason. They illuminate it so much, and this could be, of course, another possible source or another possible description of what is a bad use of lighting and what is at the end light pollution. And moving to a worldwide map, we see here that there is the black marble NASA map. This is not a new one. This is of 2012, so it's close to 10 years ago. But we can have a global perspective how the light is concentrated in the more developed countries or in the more populated areas. This is the case, for example, of many places of Europe or the eastern side of the United States, for example, in front of other less populated and less developed areas, like, for example, all the inner part of Africa, all the Amazonas area in South America, the inner part of Australia, for example, or many inner parts of Asia. So these areas are less populated or less developed, and there is not so light. So for many times, light was associated to development, but now we know that this is not a good association, because the bad use of light is not a good signal of development. It's a signal of, let's say, overconsumption, and it's not a good signal of the health of a country. So let's move to another map. This is the World Atlas of night sky brightness, that it was, or World Atlas of artificial night sky brightness, in fact, because converting converting the signal from the satellites to some measurement, we can discover how is the sky in each part of the country, on each part of the world, country by country. Here we can see clearly again how Europe or North America is especially full of light, because the pristine sky is only in the areas that are painted in gray, with some small degradation that is painted in blue, and going up until red ones where Milky Way is not observable, and the white colors where the vision is like daytime. It says cones of our eyes are active, so it means that we are working as daytime during nighttime, because there is too much light. In my location, for example, that it's somewhere here, it's not easy to see here, but not every part of Spain is in yellow and green. There are the inner parts are with some dots that are blue and sometimes close to gray. In the case of Montsec, we are in a blue area, that it's an area when we have only some effect of light pollution close to horizon coming from the distant locations. And let's move now to your country. I tried to find the Philippines map on the World Atlas, and I put it here together with the Google Earth map. And this is the situation coming from the World Atlas. So where you can probably, your country very well, and this is not the case that I have never been there, but you can see there are some spots that could be probably linked to some cities or some activities that are creating a lot of light, let's say, or using a lot of light, and other parts that are probably linked to more isolated areas that are not so, or some areas that are water areas that are on the sea. There are more or completely dark. It means that there is no effects of light pollution there. So you have a mix also of areas that are very illuminated, because probably linked to the main cities, and some areas that are almost pristine, and that could be useful for astronomy activities if they are possible to reach there. Sometimes here and all around the world, we have very pristine areas that are in the middle of natural or national parks that are not accessible for public, or that are impossible to reach for any protection. And this means that we have very dark spots that we cannot use it for astronomy, but they are there in any case. And I overlap here the two maps, and here you can have a better view of what I tried to say before. There are some areas here that are really dark. These are areas that are also without lights, and you can see here that this highest concentration of light in the main cities here. So we can have a view of how is a country, just checking the world atlas, because we can identify the mainline sources that are normally linked to the main populated areas or the main developed areas if they have industry or some kind of activities that needs or uses a lot of light. So with this initial description, we can now define what is light pollution. Light pollution, we can say that this is inappropriate or excessive use of light is what we can call light pollution in general. But we can we can use some definitions. So, for example, according to the International Dark Sky Association (IDA), it is any adverse effect of artificial light, including sky glow, glare, light intrusion, disorder in the use of light, reduced visibility at night, or waste of energy. We have some. Okay, we have some voices entering there. Okay, so this is the definition according to IDA, and according to Catalan regulations. I will talk a bit about our case. The Catalan regulation, it's very based on scientific definition of the night sky brightness. So it is defined as the light pollution is defined that the increase in the brightness of the natural night sky due to scattering and reflection of light from artificial lighting. So it is linked to the measure. If we measure that the brightness of the natural sky is increased, it's because there is light pollution. And this increase in artificial light disturbs and alters the properties of the receiving medium. This means that it's affecting the sky or it's affecting a natural area. In Catalan law, light pollution is also considered to any form of artificial light that affects a receiving environment other than the object of the lighting. For example, si we have to if we have to illuminate a street, we cannot illuminate another thing that is the street. We cannot illuminate the windows of the houses. We cannot illuminate a natural area that is in the other side of the city. If we have to illuminate something, this is the use that we have to do with that light. This is what any other use is considered a bad use of light, and is considered light pollution according to the regulation that we have here in Catalonia, in the autonomous region of Spain, of Catalonia. We have a specific regulation. And let me try to show you a short video. It's around 4 or 5 minutes. Maybe you have seen before. It was developed some years ago, but I think it's interesting. Let me say if you can listen the audio. If not, I think there are some text explaining. Let's see if it's if you cannot listen it properly and it's completely without voice. Maybe you can skip it, but let's try.
We live on the surface of a planet spinning on its axis once every 24 hours. Its rhythms of day and night are embedded in the biological makeup of all life. During the day, we bathe in the glow of the sun. As night approaches, darkness kicks in. It's a time to rest, to rejuvenate, to marvel at the beauty of the night. Until just over a century ago, our night skies were very dark. Now, even the wilderness is invaded by light. Our cities glow at night. Buildings are lit up. Unshielded lights blind us as we travel along our streets and roads. All these artificial lights power the darkness. The waste of energy is obvious, even
Excuse me, Dr. Ribas. The audio was turned off. You're on mute. Your mic is on mute. You can stop sharing your screen first and then unmute your mic.
Sorry, I received some information, but I cannot understand. So
Uh,
it's not working?
the sound is a bit faint, and
Okay.
yes, if you can louden the volume. Thank you.
Let's try again. Sorry, it's quite complicated because I'm not user of Google Meet and I don't know the details. Let's try if it works. If not, just say it, please.
brighter stars and planets pierce the glow. This is what the night sky might look like if we could remove the light pollution. That faint band of light stretching across the sky is the Milky Way, our home galaxy. Because of light pollution, many people have never seen it. Astronomers know all too well the problems caused by lighting up the night. They need clear, dark skies to study the many fascinating objects in the universe. Light pollution simply washes out their view of the cosmos. Lighting up the night sky wastes money and fossil fuels. To keep a 100-watt light bulb turned on every night for a year takes the equivalent energy output from burning half a ton of coal. Multiplied by the billions of lights blazing up from Earth, the cost of energy we use to light up the night is colossal. While lighting is needed, there are some simple things we can do to ensure that it's neighborhood-friendly, energy-efficient, and helps preserve dark skies. Light fixtures that send light up to the sky with ones that direct direct light down, exactly where we want it. They're called fully shielded fixtures. We can also illuminate only the places that need it. And of course, we can just turn off unnecessary lights. These are smart ways to use lighting. They offer simple solutions to problems caused by light pollution. We have a choice between wasting resources by sending light to the sky or learning to use light more responsibly. Light pollution is a problem each of us can help solve. Together, we can bring back the dark of night to planet Earth.
So let's return to my voice now. This was a video that was done 8 years ago by the International Dark Sky Association (IDA), also with the International Planetarium Society, to have it in full dome format to project in the domes of the planetarium, and also in flat version to be used like today. So if you look for that on the internet, you will find easily in many languages, so you can share and distribute it for free. And it's a summary of what we will do from now until the end of our meeting today, because now we will go step by step, evaluating the problem of light pollution from the components until the effects, until possible strategies to reduce it. So let's go ahead. First of all, with this, the description of the components of light pollution. We can define around 5 basic categories of light pollution. The first one is the sky glow, and sky glow, as the name is clearly described, is the diffusion of light by the air molecules and by the dust to the sky, to the atmosphere, and we can see the lights all around, like a kind of dome. And what is happening here is that the light that is tried to be used, a light beam that is tried to use it in some position, is scattered and diverted from the original path, scattering in all directions and getting at the end this kind of bubble that we can see when we are some kilometers far from a city. You can see the bubble of light above a city. This is the main description of the sky glow, and it's clearly one of the most important effects, because its effect, in the case of large cities, could affect to many hundreds of miles away sometimes. Let's see a picture. This picture is made by one colleague from Spain, Joan Mabullon. Sorry, I forgot to translate this. It's image from Pico del Buitre, and this is the name of the author, Joan Mabullon. And he's done a project that it's called Horizons Lost, because he saw that now we have very good skies in some places, but we have the horizons completely lost by the light. And this is the case of this mountain, Pico del Buitre. It's close to an astronomical observatory in the east of Spain, that they can see the lights, this the small sky glow, but still important, from Barcelona, that is 309 kilometers far from the site. So this means that what we are doing here could affect sometimes hundreds of miles away, hundreds of kilometers far from our position. In this case, they can also see the lights from Valencia, that is in the coast of Spain. Valencia is one of the most polluted areas because it's very touristic and very linked to the use of light. And this is one of the main effects. And for example, Madrid, the capital of Spain, is also visible more than 200 kilometers from the position of this mountain. So this is an example that the sky glow can be visible from many kilometers of distance with these mosaic images made by Joan Mabullon around 4 or 5 years ago. And let's continue with another one. This is the second case, is the light spas or light intrusion occurs when light is emitted in direction where it's not needed, and it's very common and in some urban areas around the world where we have the intrusion of light into homes. So we have the outdoor lighting illuminating the streets, but for due to a bad design or due to the how it's installed, we have that the light is not only reaching the ground, it's also reaching our home, sometimes our bedrooms, for example. And this could be a problem because it's disrupting our normal human activity and can create some health effects, as we will see later in another section of my presentation today. So let me show a couple of pictures also of light splash or light intrusion. Here on the top left, there is an image from New York provided by the Sky Society. And you can see here that there is this light is mainly illuminating this first floor here. So probably here there is a bedroom and they have a curtain to protect it. And here they have something that seems like an office, so they don't need to block the lights. But if you want to sleep, you have to block the lights because this lamp is illuminating mainly the first floor of this building and not the ground. And this was a null example, but very academic, let's say, because it's a terrible example. It's 20 years ago in a small municipality close to Barcelona, where the University of Barcelona, UB, had the first astronomical observatory, well, a small one, to do the lectures. Now these lectures are done in Montsec Mountains, in the astronomical park. I think in the past they were done in this small city close to Barcelona. And here you can see these ball lamps, and you can see that, for example, here on the ground, on these stairs, there is less light than here on the windows. So this means that these lamps are mainly illuminated inside the houses and not illuminated where the people is working. And this is now, fortunately, everything is replaced, but I keep this picture from 20 years ago as a terrible example of what could happen if we use this kind of ball lights. These are the less appropriated for use because they are wasting energy. Around 50% of the energy is not necessary. Let's go to the third component. This is the glare, and it occurs when we are walking around a public space or we are driving with a car. Sorry, visibility is made difficult or sometimes impossible because we have the eruption of a lot of light directly to our eyes, and we are glared, and we cannot see what is happening. And this is especially dangerous because we can have a traffic accident or we can impact with anything without taking care of it because we are absolutely illuminated, we are glared by this amount of light that is focused in an area. Glare can have also the opposite effect. Sometimes we have an area that is more or less illuminated, but quite homogeneous. And when we go outside this area, everything becomes completely black in 2 seconds. And this is also an opposite effect, but this is also a problem because we need to do a transition because our eyes need a time to be adapted to the change of the quantity of light that we have. So this is the glare. Let's see this street in the United States. I don't remember the city, but it's quite curious because here we have a lot of light in this area with a lot of lamps. They are orange. That is the good color for light pollution. So this is the best choice of color. But these lights are not pointing by the ground. They are pointing in all directions. And if you arrive by your car here and you stop here, you will be for sure glared by these lights. And you probably cannot see this area that is very dark in comparison. If there is a pedestrian here, or there is a bicycle, or there is somebody here, or something, you are too much illuminated here and you cannot see what is there. So if you are driving, you will probably have an accident here because you are too much illuminated here and too less illuminated here. So the homogeneity and the use of light to the ground and not pointing to the arrival of the cars is really, really important because it prevents accidents. And this is the case of the most dramatic case of glare when we can have traffic accidents, for example. The fourth component is the energy waste of overconsumption. And this is sometimes linked to the other ones because it is the case that we have too much energy consumption because we are using too much light or we have the light switched on in a moment that is not needed because it's too much clear. For example, if you switch on the lights 2 hours before the sun goes down, we are wasting energy because we don't need it if the sun is up, or if we use a color that it's not sensitive to our eyes. For example, if we put a lot of blue lights, our eyes are not very efficient on blue light. We use blue lights. We are wasting energy because we need a lot of blue light to reach the visibility for our eyes. And if we use another color, yellow or green, for example, our eyes is more sensitive, and with less energy, we can have the same result. This is the reason, one of the reasons that it's always recommended use of orange colors that we will see later that are better for many other things, because it's where our eye has the peak of sensitivity. So it's the best solution to put this kind of color on our streets, the traditional orange color streets. Around clutter, it occurs in the case that we have many lights, too much kind of poles with lights. We have a light on the walls. There is, let's say, a chaotic design of the illumination, and normally this is linked at the end to energy waste and to many other things. Let's see a couple of pictures of energy waste. One is a typical view of Las Vegas in the United States, when we have a light on the streets, light on the buildings. There is all around, and for sure there is too much too much light there. And the less important is the light of the streets. So it's not contributing almost anything in comparison with all the others. So it means that it was a not ordered lighting system. And here on the bottom right, we have this picture from Barcelona. This is the Olympic area that is close to the sea. Here is the beach. And this is also an old picture. Now it's modified to a better performance. But in 2001, we keep some pictures as let's say the disaster pictures. And this is the case of this area. This is a pedestrian working area with a parking area here and some main streets and an underground road here. And you have one kind of light here, another here, another here. In fact, this one that is pointing up, waiting for this reflector to do the work of illuminating the ground. And later of this picture, they added some lights here to illuminate also the beach. So there are around 4 or 5 kinds of lights to illuminate this area. And probably it will be more effective to use, let's say, this pole, for example, pointing here for the main road, and put another secondary here to pointing this area, and you don't need to use these extra lights here and here. And this extra that they have it here, maybe you can combine it with one system that illuminate both areas if you need to illuminate the top part and the bottom, the lowest level of the access to the beach. So this is a case of clutter. We have many different kinds of lights to illuminate the same place, and not a good design, a good strategy for lighting. This was very common in Spain in the late 90s, and also during the beginning of this century. And now, fortunately, this is reducing because of the regulations that we have in the whole Spain, and especially in some regions like Catalonia, that we have regulations against light pollution. Another summary picture. This is a drawing from this author from Parisia in 2013, and it is described very well the different problems that can generate a light. We can have light upwards, what is creating a sky glow. We can have some light reflected to the clouds, or light reflected from the ground. This one are creating a sky glow, but there is also an area when this light is glaring. This person is saying that he's having problem with his eyes, because there is area that's completely glared, because he can see directly the light with and it have a terrible glare effect. And also it could have this lamp is creating light trespass if entering inside the building. So this is a kind of summary pictures of some of the kinds of light pollution. Let me say that the question of clouds is quite important for me, because I did my PhD, or part of my PhD is focusing on the effects of clouds in the evaluation of light pollution. And when we are in a city, normally the clouds are amplifying the effect so much, because the light is reflected to the clouds, and we have the clouds illuminated in orange or white, depending on the color of our lamps. And on the opposite side, when we are going to a very pristine area, if we have clouds, the clouds are not illuminated because there are no lights there. And in this case, the clouds are blocking the natural light. So we have the darkest nights ever in Montsec, for example, in my area. are nights with the sky completely overcast. Why? Because these clouds are not illuminated because there is no light down, and they are blocking the light from the Milky Way, from the stars, for any other natural source. So we have a completely black sky, but we cannot see the stars in this case because it's overcast. So this is a picture from, I work in Montsec, but I live in the capital of the province, a city called Lérida, in the inner part of Catalonia, around 1 hour and a half driving from the city of Barcelona. And this is what I can see from my balcony. If I go out and I take a picture, I did this 4 years ago. And I'm sometimes when I'm doing this talk in person, or I'm doing this talk with the schools, I ask it if they can find it's like an exam, if they can find any of the kinds of light pollution that I have explained it. So, oops. And this is here, for example, in this picture, we can see here, this is a river. This is not so many full of water here, this the river, but there is a river here. And we have, for example, that this area is extremely illuminated, and there is also illuminated here, and there is illuminated in different colors here. So for sure there is a clutter, there is a mixture of combination of light, and also there is a problem of waste of energy because we are using a lot of light here, and there is also glare. Look, this, for example, I think that you can see this light is glaring directly to my position. So this means that it's because it's pointing, and it's not pointing to the ground, it's pointing to close to horizontal. So if you go by walk, you are glared by this light. And also, maybe you can see here, I think that it's visible, some dome of light on the sky. This is in orange. This is from another city, a little bit to the south of Lleida, and this is sky globe coming from another city. So sometimes from inside one city, you can still see the domes of other cities. Of course, this is more clear in the picture that I showed before from that mountain, that we can see Barcelona, Madrid, and many cities. And look at this building, for example. This building in this square is completely illuminated, and they have not illumination on the facade. And it's this is illuminated by the lights reflected on the ground. So they have, or the lights pointing almost directly there. So they have light intrusion, light trespass inside their houses. And this is happening almost in all the houses in this area, that they have a lot of light. Not in all the villages, not in all the part of the city, not in all the neighborhoods, but in this case, it's quite clear that this square is generating, because of this amount of light, light intrusion to these buildings. So this is the case, and also we are affecting a natural area, because in this river there are specific flora and fauna of the area, and we are illuminating directly the river where these animals or these species could live there, and we are disturbing their habitats. So this is something that it's quite important to take into account. So with this sample picture, this is a real picture. It's not a theoretical picture. It's a picture taken from my balcony some years ago. Let's continue. Okay, and this is another drawing. This is a summary made by Travis Longcore and Catherine Rick in 2004, and it shows the effects, also the astronomical light pollution research in the number of stars. The lights that are not shielded pointing up, we can have ecological impact, astronomical impact. The question that it was saying on the video of the impact of birds, we will go later to this. Also, there is important part here. If we use shielded light, that is okay to prevent the light pollution affecting astronomy, but it still can generate problems from the ecological point of view. Imagine that you are in a natural area, when you have an observatory not so far, and you want to keep that observatory running very well, and you use just some lights pointing completely downwards, and say, okay, I have done very well to protect this area against light pollution. Yes, you have protected for the sky globe point of view, but if you put this in an area where there are some protected species, you can generate ecological light pollution too. So it is not only using shielded lights, it's also the use of light when and where is needed. So with this, I have finished the block of the component of light pollution, and now let's see the effects. That was the main topic of the talk, saying that it's multidisciplinary effects. And let's go to these 4 blocks to discover the effects of light pollution in the different fields. Not only astronomy, I said before, my background is from astronomy, but after many years working on light pollution, I have been in touch with many people that are working in these fields, and I'm a member of the Spanish network that we have people from human health, from biology, from energy consumption, from many areas. So this is the okay. It was a problem with the animation, but now it's okay. The effects of on astronomy. Let's say the astronomy was the first to be noticed because the destruction of the opportunity to observe, because the diffusion of the light to the sky blocks the capabilities to observe from near cities. 100 of years ago, observatories were more or less located on the cities. This is the case of Barcelona, for example, or Paris, or London. Sorry. And now the observatories are installed far away from the populated areas because of the light. But 100 years ago, it was normal to have an astronomical observatory inside the cities. So these lights that are going to the sky reduces the capacity, the ability to observe objects with the bigger telescopes, but not only affects the professionals, it's also affecting amateur astronomers, because they have to directly escape from big cities if they want to do their observations for amateur purposes, just for fun or just to take pictures. So this is a global effect on all fields of astronomy, not only professionals. It's also affecting amateur, and it's affecting not only people that are doing observation, they are also astronomers that are doing modelization, but at the end they need observations. And if the teams linked to observations cannot work because of the light, also the teams that are working on modeling or on theory cannot have the right inputs to do their models or simulations. So from the cultural point of view, the destruction of the night sky is the destruction of a basic human right, because we can have a loss of cultural heritage linked to astronomy. For example, for sure, in your country you have popular names to define constellations or stars or some astronomical phenomena. It happens all around the world. But because we have around 60% of the world population that is under a polluted sky, this is almost everybody in Europe and the United States, this means that we cannot see, for example, the Milky Way from the main, let's say in the whole Europe, we cannot see. And let's say that also in almost all the main cities around the world, it's not possible to see the Milky Way. So we cannot expect that some traditions linked to the popular names or some traditions linked to the Milky Way can be transmitted from parents to sons and daughters. Why? Because they cannot see the Milky Way, so they cannot explain to the next generations these traditions or these names. And this is a big problem, not for research, not for our daily activities, but from the historical and cultural point of view, because we are losing our heritage with some traditions linked to the names and stories linked to the observation of the night sky that our grandparents probably had the chance to observe it, and more generations ago they observed it clearly and explained it to next generations step by step, and now we have more difficulties to explain any of these, and this cultural heritage could be easily lost, especially in Europe and of course in the United States, when there is almost no chance to see the Milky Way where people is living. A comparative picture, this is the Orion constellation, and this is a picture in a pristine sky, and this is a picture of the same area in an area that is illuminated with an important sky globe. We can still recover part of the structure, but we cannot see the details. So this is what is happening with astronomy. We are stopping to see this to just see this kind of images. And this is the problem that we can have. So let me show this sentence from Seneca, Roman philosopher that lived in current Spain in the 1st century, and he said, if the stars, instead of shining continuously overhead, could be seen only in one place on Earth, humans could not help but wonder to contemplate and admire the beauty of the sky. So this means that if in that moment, in 2000 years ago, there were no artificial light, so everybody could have the chance to see the stars easily. But 2000 years later, what is happening is that if you want to see the stars, we have to go out and take our car, or sometimes still go far away to see the stars. So this is now the humans are moving from one place to another to discover the beauty of the sky. So Seneca, 2000 years ago, was announcing what is happening now. That, for example, in my location, my working location in Parc Astronòmic Montsec, people are coming from all around Catalonia to see the stars and discover the dark sky, because there is no many places where it's possible to do astronomical observation, and especially if you are close to the coastline or close to the city of Barcelona. So people are in some way going to this area to discover the sky. So let's move to another effect. I'm an astronomer, and I talk just a bit about astronomy because I think that it's quite clear for all of us the problem that we have with the light from the astronomical point of view. So I will move now to another bit. It's not my topic, but I think it's important for all of us to know what are the other effects, because this could help us in our strategies to protect the night sky. About natural environment, this is an experiment made by William Beebe in 1935. He was a naturalist that was traveling around the world, and he decided to do some tests with different kinds of lights in Bermuda, and he found that some fishes are reacting more to some kind of lights. So in some way, he are doing the first test on effects on animals, but he probably has no idea that he's doing tests on light pollution effects on animals. He was doing from the naturalist point of view about how animals are reacting to the light. And what happened with this idea? On natural, okay. And the effects of the natural environment, it's mainly focused that all the species are trying to take advantage of the benefits to be in the dark side or in the illuminated side. So nightlife is a good option to not be visible and not be catched by a predator. But there are also some predators that use the night to be hidden to catch prey. So this is the typical dynamics that we can have in nightlife. Also, let's say that the temperature and humidity on nighttime are normally more comfortable than during daytime. This is not happening in all around the world, but in many places it's normal that we have too much warm in summer during daytime, and nighttime are more temperate and with better humidity levels. So this is why we have at the end a lot of species that are mainly nocturnal. Not only animals are affected, also vegetation, and we will see later a nice picture about vegetation. There is a nice sentence also from Catherine Rick and Travis Longcore, two naturalists that were probably the first one working on the effects of natural environment, saying this here. And if we wake up one morning and realize that all the preservation strategies of the last 30 years only tell half the story of the day, because all the natural plants are normally designed from the daytime perspective and forgetting the nighttime perspective. And we have more than 50% of living beings that are nocturnal. In the case of butterflies, they are 80%. Birds are doing the migration flights 65% of the time during nighttime. And the amphibians are mainly, almost all are nocturnal, 93%. Bats are all nocturnal. And rodents, mammals are almost all nocturnal. And also there are species that uses bioluminescence to communicate in the night environment. For example, fireflies. There are many kinds of species that use the bioluminescence to find a couple to they can start the reproduction process and have the chance that this species survive. And there are others that using the light as an attractor to catch some prey. This could not work if we have a lot of light. Around our eyes, this is the response of our eye. We can see from the, let's say, this purple or violet until the red colors. This is for 400 nanometers up to 800 nanometers, more or less. And you can see here some cases where we have different responses to the light. For example, in the case of reptiles, they have a better response on the infrared, but it's a rare case because all the other are mainly having more response on the ultraviolet than our case. So if we use a lot of blue and violet light that are mainly focused on this part, we are not disturbing reptiles, but we can disturb insects, many birds, and some of the amphibians, and they are more sensitive to the violet colors than in our case. For example, mainly all the insects are blind to red color. So if you red color, insect will not go there. This is the reason that in many places it's used some blue and purple lights to attract insects to not disturb, because the insects go to this color and not are going where the people is. But another option is simply use orange or red colors when we are, and probably insects will not go because they are not attracted by these red colors because they cannot see the red color. So what I try to say here is that there is a different response, and we have to take into account not only that we have to see properly, that our central point is in these colors here. If so we use illumination on the borders, we have to take care because we can disturb other species that are more sensitive to other kinds of colors or other kinds of light, like ultraviolet or infrared. Let's continue with the effects. The effects on flora. This picture is the best picture I have ever found. And it's somebody sent me, and I'm still looking who sent me this picture to put the authors here, but I don't know who sent me this picture. And this is a tree where some of the leaves are still up, and some other part of the tree are with the leaves that are simply disappear because there is this autumn or winter, and they are disappearing. So what is happening here? That we have a light here. This is the case where the light are illuminating trees, and tree in some way thinks that it's still summer and try to retain the leaves, thinking that it's still summer with a lot of hours of light, and they still is active. Another part of the same tree, because it's not receiving light, is already working on the winter strategy to stop activity, and the leaf will fall down and go to the relaxing stage until next spring. So this is a real picture. There is no trick on it, and these things could happen and could be observed. Also, on flora, it's important to know that a lot of pollinators are nocturnal. So if we have a lot of light during nighttime, some of those pollinators could not work, and if we lost pollinators, we lost everything, because it's the first stage on the trophic chain that reach to our species or to any other animals, because we need that these pollinators work, and we have fruits, and these fruits can be eaten by us or by any other kind of animals, and so on, and everything starts. They are on the beginning, on the line of the structure that we can keep us alive. around insects. These are the mainly pollinators that we have. These are images from Shimo Vacheires. Shimo Vacheires is a researcher on insects and the effect of light on insects in the University of Valencia. And what he is doing in many projects is to evaluate what kind of light are attracting different kinds of species. And they prepare some traps to catch these butterflies to evaluate what are the proper lights to be used in one case or to another. And they discovered, of course, that the white and blue lamps are normally attracting so much insects that if they use any kind of light. And also this picture is using ultraviolet, and they have some a lot of species going there, and this light is almost not visible to us, but all the species from insects are reaching there also in the same way. What is happening with the insects? In the end, the insects, when they can see a light, what they are doing is go to the light with what we call the fixation or captivity effect. So they are attracted, start to do turns around until they probably die by stress, or they simply touch the light. If it's warm, they can be burned and die also for this reason. So this is one of the problems that the insects could have, is the fixation or captivity, when there is some light that attracts them to there and are disturbing their habitat. This is the crash barrier effect. This is very common now in Europe, that we have a natural area and there is a pedestrian path, and people want to go to run at nighttime or to walk after work, to walk around, and they want to have light. So what happened? That the municipalities are in natural environment putting some lights here. And what is happening? These butterflies that probably normally are using the moon as a guidance to orientate, they found a lot of moons in the middle, a lot of lights that are like moon, and they can be completely disturbed and be trapped in this barrier, what is called the crash barrier effect on insects. There is also another effect, that is the vacuum cleaner effect, where insects that will be probably in one area, if a light appears in another area, will move from their natural environment to another environment, with all the problems of caption and fixation that we have seen before to be affected by the light. But in any case, they are moved from one part when they live normally to this new site, because there are lights that attracts them so much. So in some way, they are vacuumed from their habitat and moved to another place, and also vacuumed from the area, because if they die at the end, what we are doing is cleaning the area of insects that think, okay, insects sometimes are something that are disturbing us, but as I said before, they are very important for all the ecological effects and ecological equilibrium of our habitats. About some consequences of the insects, it's for example, an insect that is exposed to a light bulb for 10 minutes can be blinded for around 30 minutes, so can be easily preyed by another species, and also they cannot put eggs properly on the right place, and this could lead to the loss of some species from the area. And as I said before, linked to the bioluminescence and the emission of sex pheromones, they can be dramatically affected, and some species are simply excluded of an area because they cannot reproduce, they cannot communicate by bioluminescence, and they need to move to another habitat. This is the case of the fireflies that I explained before. And there is an interesting effect on their movement. I say that there are some insects that they are using the moon to find to orientate in some way, and it's well known. For me, it still sounds impossible, but it's true that there are some species that are some kind of bugs that they are using the Milky Way as the navigation source. So following the Milky Way, they know where there is their home, and they know how to return home in nighttime after looking for food. These are just bugs. They are some kind of small species then and they use the Milky Way. It sounds impossible, but especially say that it's true. So if we have light there, they cannot find the Milky Way and they cannot orientate, and they will disappear from that habitat. Let's move on birds now. Birds could be completely disoriented and impact against buildings or towers if we have a lot of illumination. These pictures are from this. In this case, this is a study done in Toronto, and they found more than 100 birds dead from impacts to buildings in 3 months in the city of Toronto. This study is done in many cities, especially in the United States and Canada, because they have main buildings and they are in the middle of some migration routes that are going from Canada to the warm waters of the Caribbean Sea. And if these birds found big buildings illuminated, they can simply be disoriented and impacted with the building or with the ground. Here, for example, is the tributary light in 2010. So this is about the 11th September event in New York and the United States. Every year they are doing some tribute, and the first time that they use this tribute in light to put some lights pointing to the sky is September. So September is a peak of the migration routes above New York City. So what happened with the switch on of the light? Around 10,000 of birds were disturbed and keep trapped on this light trap that was the use of this light. So this was for sure an important tribute for this society, but they are generating a big problem on the migratory routes of the birds in North America. So this is a clearly ecological impact. Sorry for this slide, it's in Spanish. It's provided by Ángel Morales from the University of Valencia that worked studying some birds in a natural area. Let me say that in case these species that are common in that area in the eastern part of Spain, they are doing things during nighttime that are normal during daytime. These first 300-400 means that they are looking for food. These species are looking for food during nighttime if there is artificial light. These 2 ones are, for example, singing close to the lamps on the streets, probably thinking that they are at daytime and they are just singing like during daytime. Or this one was the case that because they have some light coming from a window pointing to its nest, she was feeding her kids during nighttime because there is light in the area and it's thinking that it's daytime, and it was feeding the kids. So it's some examples analyzed here in the eastern part of Spain of some kind of birds. There is another bird that is important in the study of light pollution. This is the case of shearwaters. In Spanish, we say this pardela. I don't know the name that you can use for these birds. This bird is it's quite curious because it's normally born in close to the coastline, normally in Iceland or an area that they have the ocean very close. And after some weeks or some months on the ground, they fly to the ocean and remain during around 3 years flying on the ocean and just not returning to the ground until they are enough old to look for a couple and continue with the species with creating a new nest and so on. So what is happening here is that these birds need the darkness to look for the ocean, because the wave of the ocean, the wave of the sea, help with the light from the stars, the light from the Milky Way, the light from the moon, create this effect, and they can identify by this illuminated ground that this is the ocean, and they know how to go to the ocean and start their trips. What is happening is that if the ground is illuminated, they thought that the ground is the ocean and go to the ocean, but it's not the ocean, it's the ground, and they can be can impact with cars, with people, with buildings. And this is around, only in the Tenerife Island, in the Canary Island, there were around 800 Scopolis shearwaters. It's one of the species that can have accidents every year, around 800. This is a big number for a species that it's not not a species with a very big number of members in the area on Tenerife. This was also studied in Australia and in other places. It's a curious case. On bats, as I said before, all the bats are nocturnal, and it's known now that there are some bats that are looking from for nooks and crannies to be hidden from the light. So they are not simply remaining in a building or in a rock. They need to go very inside to be hidden during the day of the light, and also during the night, because they receive light also nighttime and need to be hidden from the light. Also, they are also affected by the lights from the feeding point of view, because if there is a lot of light, there is a lot of insects there outdoors, and they can go and eat easily. But what could happen? At the first moment, they will increase the population because it will be very easy to find something to eat. But later, if this population go up and up, at the end, there will be too much bats for the area, and this could lead to an ecological disaster of this species in that habitat. Simply disappear because there were too much bats and there will be no food for all of them. Other cases, in cases linked to animal species, one that probably you have seen in many TV reports is the case of careta careta. This is the sea turtle that they need the darkness to find the way to the ocean. When they start to live, they move to the ocean, very, very small turtles going to the ocean, and we have to prevent to be illuminated on the opposite side of the beach, because they can simply took the wrong way and go to a swimming pool, to a fountain in the area, and not to the ocean where they have to go. Also, it's known that the Atlantic salmon shows alteration after the birth, after its birth, when the salmon live normally the first weeks on the river and then move to the sea, and then later return to the river in their last days. But they need to move quite fast from the river to the sea, and it's known that if there is light on the rivers, they don't move so fast and can be late on the time of arrival to the sea. So this also affecting fishes. Another case is the plankton that are important for water purification, that there is light, they are not doing vertical migrations of plankton that are sometimes creating some bioluminescence too, and they're important for water purification. We know also there are some effects on the songs of toads due to light, and if they don't sing a song, there is no reproductive dynamics on the right way. So this is many effects on the almost any kind of animal that you can look for. You can find an effect due to light pollution. About human health, this is probably one of the areas that appeared on the studies. Artificial light is especially critical for the alteration of the circadian cycle. Our body follows a circadian cycle, and this means that the light is important to regulate the circadian cycle. And the key point is the blue light at 480 nanometers that activates melanopsin. What is melanopsin? Melanopsin is an hormone that blocks the melatonin in our body. So if we activate melanopsin, we are not generating melatonin. And melatonin is extremely important because it affects our resting cycles and our sleep dramatically. So if we are exposed to light during nighttime, melanopsin is activated and melatonin is suppressed. And with melatonin suppression, we can have many health issues. This alteration is commonly defined and known as chronodisruption. And in 2007, the World Health Organization classified it as a possible carcinogen effect because chronodisruption leads to effects linked to cancer, for example, due to this alteration of the our circadian cycle. This is why now it's very common in some supermarkets and in some places that we can find this melatonin that you can purchase there, and with the recommendation to eat it before go to sleep. If we use a good strategy of lighting, probably we don't need, nobody needs to add this to the diet, because our body can produce melatonin. But if we are exposed to light, our melatonin will be poor or will be too much slow to have a good and recover and relaxing sleeping. Let's talk a bit about the melatonin inhibition and suppression. And this happens because of a receptor that is in the human eye. We have two kinds of cells in our eye that are linked to the vision, to see images, let's say. And there is another one detector that it's just used to determine if it's daytime or nighttime. And this is the one that works with this blue light of 480 nanometers. What was done in this experiment many years ago, so this is not new. It's all I explained it today. It's things that are discovered some years ago, so they are absolutely stable. There is not something that is under discussion. Everything is quite clear. And this is the melatonin index in one person during this is the time of the day, from 4 p.m., midnight, until next day. So in some moment, when the sun go down, naturally melatonin starts to increase, because we don't receive the amount of blue light normal during daytime, and this person probably start to sleep here. So more or less is stable melatonin during this period. What happened here is that in this experiment, the persons that were studied were just illuminated during 1 hour by light. And what happened with melatonin during this 1 hour? They are probably continuing sleeping, but melatonin go down very fast. And with this reduction of melatonin, when the light was switched off, it starts to recover again. But probably during this period and this period of recovery, the sleeping quality of these persons were really poor. And so this person probably was sleeping from here to here, but the good quality of sleeping was just on this part and this part, with some disruption in this part. And nice thing is, this effect is also detectable in blind people, because this detector could not be affected in some blind people, because it's another detector not linked to the normal vision. This is the response of this detector. These are the cones that are colored cells to detect different colors, the blue ones, the green ones, and the red ones. And these are the rods that give us especially information during nighttime. And this IPRGC is this special ganglion detector that is just centered on these 480 nanometers on this region, to determine if it's daytime or nighttime, to activate or suppress some of the hormones to regulate the sleeping time. So more on human health. Melatonin is an antioxidant agent, so this is oncostatic, prevents cancer, and the main function is to sleep preparation and as a regulator of sleep-wake rhythm. So it's important to have a good sleep for our health. So this is why melatonin is important. But it's also have some links to immunity and a regulator of reproduction. So they have many effects on our body. So good melatonin levels have been shown to have lower incidence of many kinds of cancer. Breast, prostate, colon, and endometrium are less affected if this person has good melatonin levels. So this is why it's important to have good melatonin levels, because sleeping well means less risk on all these kind of things. It's well known that shift work, especially people that work with night shift, they have more chrono disruption than the normal population, and they have more effects. But this also happened with with patients that are hospitalized with the lights on the whole day, or for example, babies in incubators, if they have all the day and night the lights on. This is why now the hospitals, also in very specific areas where they have to keep the patients with special treatment or so on, they are doing the switch on and switch off. During the nighttime, they switch off the light or reduce as much as possible, because our body needs the darkness to recover our health. So we need this rhythm of light and dark system in order, systematic, day after day, and it is good for our health. And there are relationships found between coronary eruption and many health issues like obesity, diabetes, some coronary heart diseases, and with what is called oxidative stress. Oxidative stress is linked with aging, Alzheimer, cancer, etc., etc. So it's important to keep into account that the exposure to light at nighttime could generate in us a coronary eruption with all these possible elements that can affect us in the future. There were some numbers of the occurrence of breast cancer according to the amount of light that this person has at nighttime at home. And it's quite simple that higher levels of light at night at home have a direct link with breast cancer. This was one of the first studies that I ever found on this topic in 2008. But recently, 2 years ago, there was a study on the same line made by a team from Barcelona, Madrid, and from Canada, that they found the same correlation 10 years later. So this means that is really a link with cancer and exposure of light at night. This was also that we have a solution. We can use light if it's needed, but it depends on the kind of light. This is a work of María Mati from the University of Murcia in Spain, in cooperation with some works made by Fabio Falchi, who was one of the main authors in light pollution, the author of the World Atlas. And with this plot, what they show is that if we use orange-colored lamps, this is high-pressure sodium. In that moment, LEDs were not available. The orange LEDs were not available at that moment in 2011, 10 years ago. Now they are very easy to find, and they can be used in protected areas. They discovered that orange lights, this one that made by sodium, they have this index of suppression effect. They have lower values. This is the definition is that this one is 1. So this means that if we use white LEDs during nighttime, we have 5 times the normal suppression of melatonin. So we are having a worse effect in our health if we were exposed to white LEDs than if we are exposed to orange colored lights like sodium lamps or the now recently appeared amber LEDs. In the moment of this study many years ago, the amber LEDs were still not so common. Other effects of light pollution after health, after biology and environment, after astronomy, is the energy spending. We are spending the double of what we had in the 70s and to illuminate the streets. Why? If every year we have lamps that are more efficient, so why every year we are wasting more energy? This is the reason, because if we have more efficient lights, we are not using the same amount of light. We are using more lights. Because they are cheaper, we use more. And because we use more, at the end, we are having a waste of energy. This is a typical effect that the lighting engineers found in any change of or in any evolution of the lighting industry. When we have better lights that are more efficient, we are not using the same amount with more efficient lamps, so reducing the power consumption. What we are using is because now it's cheaper, now it's more efficient, we put more. And because we put more, at the end, we spend more money and we have this waste of energy. So in air pollution, of course, the energy consumption is generating a direct effect on air pollution. We know this, that we have a problem of air pollution all around the world. And but there is a photochemical reaction during nighttime that helps to reduce air pollution. When I discovered this, I was absolutely surprised when I read this information 5 or 6 years ago. So the presence of light at night destroys some radicals of nitrate and increases the presence of ozone polluting at the end the air. So know that there is the ozone layer on the top of the atmosphere that it's very good for touch preventing us of ultraviolet rays, but there is the ozone that is a pollutant that is on low levels. So the light at night is preventing the destruction of this pollutant, of the ozone pollutant. So we have some reactions that need darkness in the atmosphere that are good for us because they reduce naturally the air pollution. These are not extremely important in comparison with other elements of polluting the air, but are on the same way. If you want to have clean air, it's better to have night with less light than not completely light polluted. Around safety, night lighting started from the beginning to give safety to the people in some way, but now there are some results, mainly the studies made by Paul Marchand from the University of Leeds in the United Kingdom that have analyzed crime, road safety, with many statistics that are available around the world, especially in his country, in the United Kingdom, but all that they can get, he's analyzing with many details, that now we know that more light is not linked to more safety. So we can have more accidents, we can have more crime with more light than with less light. So this not means that we have to switch off everything. This means that putting more light is not helping to reduce problems linked to safety. Let me see an example. Let me show an example. This picture. I don't know. This is one person in the United States that decided to put a lot of light on the garden to be sure that if somebody arriving there he could see if there is somebody there or not. What happened is that there is a person there, but he cannot clearly see here. Now probably you can see because on the screen is quite easy to see, but if we show this in person, you cannot see there is somebody here. You can see just the light, and the light blocks you, glare you to see if there is somebody on the wall of the garden. So if this person decided to put light to be more safety, it was not a good solution, because with this light, what happened is that the intruder could see us before that we can see him. So it's working on the opposite direction of safety. So this means that not more light, it's always more safety. Sometimes it's just on the opposite direction. It's just a trick example, but it's interesting to know that if we want to illuminate, maybe it's better to use some sensors that activate the light if there's somebody there. This is very useful because if the light is on, it means that somebody is there. But the use of lights in all the moments and with a big amount is not helping to increase our safety in the surrounding of our houses, for example. So I have finished the part of effects and characteristics and effects of light pollution, and now I will talk a bit about how we measure light pollution, and we'll apply a little bit to the case of Montsec, and this will be the final part of my talk. So to measure light pollution, there are two main approaches. One is the satellite imagery, as we explained before. This was the first wall atlas. We are here in Montsec. We are in this blue part here, just here. This arrow is not quite well. We are here in this blue part. This is Barcelona. These are Balearic Islands, for example. This is Barcelona, and we are in this part here in this blue area. That it's the area we have some only pollution on the horizon and not up. And also we can combine this with the ground measurements. One possibility is the all sky images, for example. This is an all sky image from the top of the mountain of Montsec, and this is the Milky Way, for example. And these red dots are in the horizon, the sources of light pollution that we have. This is, for example, the light coming from Barcelona, that it's more of 100 kilometers from the position of the astronomical observatory. And these are the lights coming from Lleida and Balaguer, that are medium and small size cities that are around 50 and 20 kilometers from the observatory. These are, in the case of Lleida, that is this one here, is a city just where I live, of around 150,000 of inhabitants. So it's a medium-sized city here. And this one is a small-sized city that it's Balaguer. It's around 15,000 of inhabitants. All the other cities, all the other villages surrounding Montsec area are not detected here because they are small villages with around 500 inhabitants or sometimes less, and with the good strategies of lighting to protect the area of Montsec. Because the important thing that we do there is to define a strategy of protection to replace all the lamps on around 20 municipalities around the location of the astronomical park and the astronomical observatory to keep the surrounding as clean as possible of light pollution. And this reflects on this measure of the sky. Here, for example, we have these values between 21.6, 21.9 magnitudes per square second. This, the ones of you that are linked to astronomy, we measure the stars in magnitudes. And when the number is bigger, fainter is the star. So these big numbers means that the sky is extremely fainter. A natural sky is around 22 magnitudes. A polluted sky like the one that we can have in Barcelona is around 17 magnitudes. It's 4 magnitudes brighter. That this 4 or 5 magnitudes brighter. This means around 100 times brighter the sky in Barcelona than we have in Montsec, for example. So in the cities we can have 100 or more times brighter than the natural sky that is linked to these values of magnitude. One mode to measure light pollution is using the classical astronomical photometry. This was the first technique that we used it in Catalonia. Sorry. This was my first job in the university in 2000. And we used a telescope, a CCD camera, with a filter wheel, and we observed the sky in different positions and use the stars as a calibrator. So using the stars as a calibrator, we can do photometry. As in astronomy we do with some stars of reference, we measure the brightness of another, and we can discover information of this a star, for example, if it's a variable star, or if there is a star that's having some transient effect, we need some stars to compare. Here we use the stars to compare to define a fitting that allow us to know how is the background of the image, how is the levels of the natural of the night sky brightness, let's say. And this is a map. In that moment, it was extremely slow to do this. We need 4 or 5 hours to measure the sky, and we saw that the darkest values are on the zenith. This is an all sky perspective, and this is horizon, this is zenith, and we studied some directions to determine where the lights are coming from. This was the first technique used in Catalonia for the Catalan law, because as I said before, and I will introduce some elements of our legislation here, our regulations here, is that in 2001, Catalonia made the first regional law in Spain. That was the Catalan Against Light Pollution law, and it was approved in 2001. And in parallel with this improvement, is these measurements to study and to discover how was the sky in that moment were started in the University of Barcelona when I worked in that moment. We can measure also visually the light pollution without any instrument. Any one of us can do it, and the techniques are naked eye techniques. For example, with the method observation chart, that is the star count. So with this one, what we are doing is discovering some way until what magnitude we can see the stars using our naked eye. I saw before that there was a question appearing there that I will now automatically answer it. The one asked about how far we can reach with our naked eye. I saw here appearing in some description. In some way, I'm answering now. With these meteor charts, with what is called the sequence of the celestial North Pole, that is to follow a star from the North Pole every time fainter one after the other until you cannot see it. So the last one that you can see is your limiting naked eye magnitude. This is the limit of the quality of the sky where you are observing. And so this is the value of light pollution, because you are seeing I can reach up to stars of magnitude 5, 4, 3. Normal sky is around 6.5 or 7 if the conditions are extremely good. You can observe stars until magnitude number 7 with a very pristine conditions. Fainter than this, it's not possible because the limitation of our eye. But if you are in a city, you have light, you can only probably see the stars that are brighter, magnitude 1, 2, 3, something like this. And so using these techniques with meteor charts, with the sequence of North Pole, or with some citizen project that uses some charts, like the Globe at Night project, you can determine your limiting magnitude. And with your limiting magnitude at a naked eye, this is a measure that can be added to Globe at Night and is contributing to this global study on how is the quality of the night sky. So this is the limit that we can, of answering that question. The limiting magnitude that we have, it depends of the night sky brightness, but it's also a limit on our eye, and it's up to magnitude 7 at naked eye. Also, we use a telescope. The limits are linked to the telescope and also the night sky, but it's linked to the telescope. But if we use our eye, the maximum that we can reach is up to magnitude 7 in very pristine conditions. This is not the normal one. This is in very pristine conditions. They are available some mobile apps that could help us to do measure of light pollution. This is the case, for example, of Dark Sky Meter app based on iOS system. This is a thing that it's not for free, but there are some promotion in some moments to use it to download it for free. And it take a picture with the iPhone camera, one with the cover on it, another one with the pointing to the sky, and we can get information about the measurement in the same units that is appear here, SQM. This is a device that I will show you later. This is sky quality meter, is the most common device. So this is the measure that this phone measured, and it's equivalent to a measurement of SQM of 15.14 magnitude. So this means that this sky is very polluted because it's for 15 to 22, that is the pristine, there are 7 magnitudes, and this is more than 100 brighter than normal one. And this number here, is the limiting magnitude at naked eye. So with this sky, you cannot see anything fainter than 3.6 magnitude. So you look for a chart of stars, you cannot see anything fainter than magnitude 3, 3.5 in a sky like this, because of the one is linked to the other, and one can compute from one to any other with some approaches, but you can do it. And the other application, the other app that we have is the Lost of the Night app, that it's available on Android mainly, but it's also now working on iOS. And this one helps you to find stars, and you have to see if you can see it or not. And if you cannot see, you have to explain why. If there is some clouds, you have to say, no, I cannot see because there is a cloud there, or there is a building there. And after some statistics, after looking for around between 10 and 15 stars, you can receive the number. This number of the limiting naked eye magnitude that give you an idea of the quality of the sky. These data are also stored on the Globe at Night project database. So any measurement done with Lost of the Night app or with Dark Sky Meter app is also contributed to this citizen science project called Globe at Night. Let's go to some instruments. Now we are using, I have explained the classical one with the telescopes, and I explained it what we can do without a telescope or without any device, using our phone or simply downloading some charts and participating in a citizen science project online. But we can use some instruments too. Some of them are cheaper, some others are more expensive. These ones are the cheaper ones, that are the sky quality meter, SQM, that I said before. And this is a standard one. And there is a handheld version. You can press a button pointing to the sky, and you can get the value of your sky at that moment. And of course, these are tests indoors with a lot of light, because 10 or 9 magnitude is extremely bright. But this is this case. And what we can do with these devices? We have done, for example, in the case of Catalonia, to define these strategies of protection, we have done two kinds of measurements with these devices. Using ones that are not by a button, that are not handheld, are used by a cable, USB cable. We put it above a car. We have defined the housing to be fixed above the car. We put the instrument here, and we measure from inside. And with the computer and with the GPS and this device, we are doing is mapping the area. So moving with the car and taking lectures of GPS and sky quality meter at the same time, and having a table that we can convert later to a map. This was part of my PhD too, and we created the first versions of the Catalan map of the quality of the sky. Have done in cooperation, Astronomical Parc of Montsec, University of Barcelona, and the Catalan government with the service against the public service against light pollution. And this was a good technique to cover areas using a car to move around. Also, these devices could be used as a monitoring station. And this is a housing. This was an old system that now we have replaced it for a better one, but it was the first one that we had in the Astronomical Park rooftop. And we can put, in this case, were 5 slots. Now we have one with 20 slots. We can put some devices that are also by a cable, like this one. This one is USB version. That one were Ethernet version. This means that we have an Ethernet cable moving out to this box here connected to the general network of our building, and we can read in any moment the measurement of these devices, so we can have a monitoring network. We can put these devices in different points of Catalonia. This is what we have done. We have around 12 devices running in Catalonia now, and we receive all the data, and we can monitor night after night, every night. We can get the quality of the sky in these places, and we can do some statistics to discover if things are changing during the year, if it's changing year after year, and so on, using this SQM as a monitoring device in a permanent position. This was the test area when we put 5 every time, and now we have a space at up to 20 to calibrate at the beginning. We calibrate all of them to be sure that all are measuring the same, and then these devices were to different places around the country to do the real measurements for the pilot plan that is a Catalan network on light pollution to this evaluation of the quality. The case of Montsec, we're mixing techniques with our case. This is the case of Montsec. This is the astronomical park is located here, and this area is around 40 per 40 kilometers. And this was one of the first versions of the map covering this area. Now we have a map that covers the whole Catalonia, and we are still running new areas year after year. After 9 years of working, we are close to complete all the natural areas of Catalonia to have this global map, global from our point of view, because not only covering the area of Montsec, covering all the country with quite accuracy to find better places for to be protected, or to find places that are potentially a problem in the near future. And the darkest colors means higher magnitude, means darker values. This is 22 is the natural sky. So if we have more than 22, it's because something is not working very well, because we can have some blocking elements like clouds or something. But here in Montsec, we still can find 22 in some areas that are extremely pristine. And here painted in red and in green, there is some sonification that we did because we decided to apply for quality certification. There are quality certification of the International Sky Association and quality certification of the Starlight Foundation based in Canary Island. And we applied for in that moment, 2013, with the preliminary version of this map, we applied for the certification of a Starlight Reserve and a Starlight Touristic Destination for Montsec. Montsec is this mountain here, and here is the area where the astronomical park is located. But it's a mountain of 40 kilometers long. And the interesting here is that this area marked in red is the area that we have normally values darker than 21.4, except inside the villages that are more bright, of course, because of the of the light of the villages. But outside the villages, we have during the year, the most common value is better than 21.4, and this area was defined as reserve. And the green zone is the area where the values are between 21 and 21.4. This area could be certified as touristic destination, but not as reserve. And this was the certification that we got in 2013, and with a renewal in 2017. And now we are working in the second renewal of this Starlight certification. This is okay, too fast. This is what we can get using this movement techniques with SQM moving with a car to get this kind of maps as bigger as you can do during different nights, integrating data to cover waste areas to have these general maps. Other specific instruments that we can use are one-dimension instruments like the SQM, but there are other ones. This is called the light meter, that it was like a photocell that was developed for the International Year of Astronomy in 2009. Now it's not very common to find one, but there are also like DigiLum that was specially designed to measure with the response of the eye, the photopic filter V. There are only just 2 or 3 devices available around the world, and are good for calibrator, but are not something that I recommend to anybody to buy because it's extremely expensive, and there are other tools that are cheaper and easy to use. And also, by the end, we have the all-sky monitoring that are devices that allow us to get the whole sky picture. This could be a specific device like ASMON. This is the name of this device, that we have one in Montsec, but now it's possible to do it with commercial cameras. With DSLR cameras, with a fisheye lens, we can get all sky images. Of course, with these images, we need to process the data. Sometimes it's not easy, but there are some available software. Very soon, I think we will have free of use available software for many cameras. Now there are software that it's not freeware, that it's payment software, that is called Sky Quality Camera for Canon cameras, and you need to calibrate the camera in the lab, and then you get some calibration files and the software, and you can get maps from a picture with an all sky lens in your commercial standard DSLR camera. But as I said before, there will be freeware software very soon, open source software that you can do it with almost any camera with a fisheye lens. It's very, very close to appear on the internet to have this software available. These are the pictures of all sky. It's from ASMON device, a specific device that we have. This is the one that I showed before of the astronomical observatory with the location. And this is another case. This is close to a city, the city of Balaguer. It's 20 kilometers from the astronomical park. And because we are close to the city, we have this dome of light. This part marked in green. This is not natural sky. This part is almost natural. We can see the Milky Way still here, and this color, that means that we have quite good quality of the sky. But here, this is the village, the city, sorry, and we have a lot of light that are illuminated the sky, and we are losing this part of the sky. But one interesting theory is that this area, in this direction, is the direction where Montsec is located. So this means that we are on the right direction, because this is the direction that we have less light, and we are 20 kilometers from this point, and you can recover something like this. The city of Balaguer is this spot here. This is the city of Balaguer lights seen from Montsec, and these are the Balaguer lights seen from the border of the city. Of course, they are illuminating a lot on the sky. This is the sky of Montsec. This is Astronomical Park. My office is somewhere here. Inside this building, this is the planetarium, and these are the telescopes area. I show this picture because you can see here that there are a lot of stars, and we have some light here. This is it was a day that there were some high clouds in the area of Barcelona, that's 100 kilometers. And with this picture, we try to magnify the effect to see that the light from Barcelona could be seen from Montsec. These lights are coming from Barcelona metropolitan area and are affecting in this day because we have clouds. It's an important effect still on the first 15-20 degrees on the horizon. Normally, where there is no clouds, the effect is just on the close to the ground. But that day that we have clouds in the direction of Barcelona, you can see this effect. Here, I don't know if it's possible to see. You see that it's a little bit dark on the image. This is because we have clouds also above us. And clouds in a dark area are dark, are not illuminated. So when you see dark clouds in a place during nighttime, so you cannot see stars and you see something dark, it's because you are in an area that is quite pristine. Because normally clouds are illuminated by light. But if you are in a pristine area, clouds are not illuminated by light. In this case, local clouds are not illuminated, but 100 kilometers far clouds are illuminated by the lights of Barcelona metropolitan area. So it's an image to remind us that we are in a pristine area, but we have to take care because light can travel many kilometers in some conditions, in some atmospheric conditions. And I cover this with another picture of one of our activities outside of the astronomical park, because not only in the astronomical park we have very good skies, also all the area around the Montsec mountains have had very good conditions, to do astronomical activities. This is the area protected. If you remind the red line and the green line, this was the official map of reserve and touristic destination of Montsec, that it is specially protected by law. In Catalonia, as I said, we had a law in 2001 and some secondary regulations that appear in 2013 and 2015 that are doing some zonification in Catalonia with zones that are extremely restricted, like what we define E1 zones, up to E4, that are the city center, very commercial streets of the city centers. And Montsec is all of them, all the villages around, 24 villages, are defined as E1. So this is the highest restriction. This means that they cannot use any lights going, more than 1% of light going up, so they have to be full cut off at the end, and only colors without light without blue component are allowed. This means PC amber LEDs or filtered amber LEDs, or the old sodium lamps that are still in use. You don't need to replace immediately everything, but the sodium will be replaced because it's more effective than LEDs. But we have to choose for this area the amber LEDs to prevent not emission of the blue light. That is the worst for environmental, for health, but also for astronomy. In the case of astronomy, we prefer not to use blue light because they are more scattering and it's affecting so much the astronomical observations. It's better to have these warm colors, this orange color, on the streets of the cities and villages close to a protected area. This is why a Catalan regulation defines, and we are planning now a new regulation that will be more restrictive and will not allow to use white LEDs with high blue component in any place of the country. And now in Barcelona, for example, you can use white LEDs that could have quite blue component, but this will change in the next 1 year, in the next 1 or 2 years as much, because this white bluish LEDs will not allow it in any part of the. And now Spain is preparing the global regulation for the whole country, not a regional one like the one I explained before, that will allow only lights with color temperature less of 3000. This means that it's only warm LEDs or amber LEDs will be allowed. So the neutral and cold LEDs will be forbidden in all Spain. This is already running in Catalonia, but now will be in the whole Spain that will be not allowed the use of white bluish LEDs. Just a couple of curiosities from our mountain. This is Montsec Mountains. Here, I will translate this. Because we have, there is the road that go up to the astronomical park and the cars need to go there. We have put a label there saying protect the dark sky, and we have used only the short lights of the car. You cannot use the long lights of the cars to not disturb the people that are doing astronomical observation. So this is just a curious strategy to remind the people that we are in a dark area, and also the cars you need to use just some kind of lights, and not the long distance lights are allowed in this road going up to the mountain where we have the astronomical park, and in the top there is the research observatory of Montsec. So these walls on the road were just to prevent. This is Montsec Mountain. This is our center of astronomical park is somewhere here. So when you go by car, if you switch on the long distance lights here, this wall prevents that these lights from the road point directly to the site where the astronomical observations are done. So this one done in the main road that reaches the Montsec area to try to reduce the effects of the cars to astronomical observations, astronomical activities. These are just some curiosities of other kind of possible pollution coming from the cars that we tried also to deal with it to keep the sky as dark as possible, and to try to obtain images like this. These images, all of them, were obtained from different facilities in Montsec Mountain. This one is from Flame Orion area. It was made in the astronomical park. This one of M81, M82 galaxies were also from the astronomical park, and this one were made by amateur astronomers. They have a observatory camp 1 kilometer from us. This was a globular cluster, and this planetary nebula was made by the research telescope. That the main topic of research telescope in the top of the mountain is not to take nice pictures, is to do research, but they have some nice pictures, and I have added this one too to show that from different points of the mountains we can get images like this with our telescopes and our devices. So let's go to the end to what can I do? What can I do? So first of all, from our home, using the right outdoor lighting. Use it when and where is needed. Not all the time, not at maximum level. If we have a garden, just put the light with some sensor, switch on and off if there is somebody there. At the end, as I said before, more light is not more safety, because sometimes this light helps people to access to a house to do bad things. So it's not clear that put a lot of light in the surrounding of a building is good for safety. Sometimes it's a help to people that are trying to do a robbery or something like this. The other thing that we can do is disseminating the problem to our councils, to our institutions, explain that we can have problems in some areas, that we have light coming into to our houses, that we are destroying the sky, always from the dialogue perspective. We don't need to fight against anybody. We have to explain, we have to communicate the problem and try to prepare solutions. So our councils, our institutions will listen our explanations, and they can act together, not just fighting. Only with fighting we will not solve the problem. We need to find agreement and find a way to get regulations that will help us to save our skies. What more things that we can do? Contributing to measurements, having more measurements or better measurements with visual, with the charts, apps, or we have SQM or any other device, and integrating them to the global databases or citizen science project like Globe at Night. This will help to have a global perspective of how is the night sky all around the world. In comparison with the World Atlas that was made by satellite, we can have some ground measurements that will help to get a better perspective to the scientific community and to all other institutions, how is our sky. We need to still more, maybe more active. We can integrate in a supporting group on defense of the night sky as the International Dark Sky Association, that there was a global one with bases in the United States, or for sure it could be national or regional associations that could help us. Maybe because they are from the ecological point of view and could be interested on it, or maybe because they are especially focused on the dark sky protection. I don't know if there is a dark sky chapter in your country. If not, you can create a dark sky chapter linked to Dark Sky Association in your country. In the case of Spain, it's called Selfosc. This is the words in Catalan, not in Spanish, because this association started in Catalonia and then became global in the whole Spain, but remain the name in Catalan, Selfos. In Spanish area, it should be Cielo Oscuro. dark sky in English, but the name of the Spanish association is in Catalan. It's called Cellfos. It's just one case, but in many countries there are associations or there are chapters of dark sky, or could be chapters in the near future, or some ecological associations that could be interested in night protection, not necessarily night sky. Maybe they are working for the protection of species at night, and they could be interested also in the protection of the night sky, because it's the same problem. The problem of the light are affecting animals, are affecting our health, affecting the environment, and are affecting astronomy. Let me introduce some breaking news of what we can do. There is a new project of citizen science. I have been partially involved, but it's led by Germany. This is why they started to work mainly in the surrounding of Potsdam and Berlin. This is a night lights project. This is the website. But if you look for night lights citizen science project on Google, it will appear. And you can register, and you can create some transects, some routes on your cities or your villages to cover by walk. What we have to do? Define a small route that you can do of maybe 200 or 300 meters, depending on how is your village. Sometimes to 1 kilometer that you can do by walk. And with your phone, you have to do it by walk after defining and after everything was validated by the project. This transect is added to the map, first in blue because it's ready to do but not done, and then in yellow when they have measurements. But you can go there. I will do this transect and start to walk, and you have to pressing buttons. You will just do some statistics about what kind of light can you see on this street. This means if there are public lights, or there are just lights coming from the windows, or there are lights coming from shops, there is a classification, and you are simply saying 4 of these, 3 of these, doing some statistics, and this will be uploaded. Why we are doing this? Because it's very easy to get images from the satellite, but satellite has no idea what is happening on the ground. So if we can combine satellite images with these statistics, we can know better what satellite is looking for. And we can have better results from satellite to analyze how is the sky and how is the lighting systems all around the world. And this is why they are using, you can propose transects and do this measurement, and we add it to the database. We have 15 transects prepared to do it in Azure. That is the name of the village close astronomical park that we will do next month, to add this a new point to this project Night Lights, that we could be compared ground-based light statistics with the satellite imagery that can help to get better results for the study of the light pollution and night sky brightness. So just to end with this small joke about what happened with the bugs and insects if they go to the light. This one returns, and his colleague says, "What you have done? What you have done in the Ferguson porch light?" Because he was probably flying around until he got burned and arrived in this strange condition to the home. It was a joke that appears in a journal some years ago, and it's an example of the problem of light pollution starts in our homes, and it's not affecting only astronomical observation, it's affecting also some species and many effects, as we said in this talk. And I think that's all from my speech. I have done I think maybe too much long speech, around 1 hour and a half. And thanks for your attention during this long explanation. I hope that I could introduce some new topics to your community, and you have more information. This is our webpage, parcastronomic.cat. There we have sometimes information about some of our activities on light pollution, but probably the other 3 URL are better for information. The first, YX, is the website of the Spanish Research Network with some documentation on light pollution, and then darksky.org is the Dark Sky Association webpage with many resources. I extremely recommend this webpage. And Light Pollution Map Info is a webpage with many information about the maps obtained by satellite and other measurements, so you can get better idea how is your area and what data are available from your region, your country, or any other part that you are curious to know how it is. That's all. So I'm ready for your questions.
Thank you very much, Dr. Rivas, for that very enlightening presentation. So we will now go ahead and take some time for the Q&A session. This is your chance to personally ask your questions to Dr. Rivas. So just raise your hand, state your name and affiliation, and then ask your question. So anyone who wants to personally ask their question to Dr. Ribas, you may now raise your hands using the Google Meet. So I guess no one wants to ask personally, so we will just... Ayan. We have one question from Sir Sonic Duran. So, sir, you may now open your mic.
Hello, good afternoon, everyone, and probably good evening, Mr. Ribas. It's a good presentation, and thanks for this webinar. So, my name is Sonic. I'm a Filipino, and I'm currently residing in Cambodia, and I'm an amateur astronomer, or we call astrophotographer. My question is related to basically Bortle scale. So we know one of the factors of Bortle scale is basically the light pollution. And I am quite curious if this Bortle scale, of course, we know it goes high as the light pollution increase in a city. But can the Bortle scale become lower if, for example, let's say policies will be implemented to lessen the light pollution in the area?
Sorry, I had not microphone on. Okay. About around Bortle scale, let me say that scientific community is not very comfortable with Bortle scale, because at the end, Bortle scale, what it's doing is to define some elements to classify the quality of the sky. For example, Bortle scale 1 means that you can see Guggenheim, or you can see zodiacal light with color, and there is no lights on the horizon. And you can see, I think this M33, the Triangle Galaxy, without a telescope. Let me say, for example, that in Montsec, we can see the Guggenheim, we can see zodiacal light, we can see M33, but we have lights on the horizon. So, according to lights on the horizon, we are Bortle scale 2, and according to some other values, we are Bortle scale 1, because the difference between Bortle scale 1, 2, and 3 are extremely small. So this could be, this change of Bortle 1 to 3 could be just simply for some air conditions in a specific moment. So we don't like it, because it's not very realistic, because you think that if you have Bortle scale 3, you could be frustrated because you are not an excellent dark sky site. Let me say that if you have a Bortle scale 3, probably you have many features of Bortle scale 1, depending on the days. And many people that have areas, remote areas that have a Bortle scale 1, some days they will not have Bortle 1, because they can have some air conditions that are converting this 1 to 2 or 3. So these 3 first slots of Bortle scale could change not by light conditions, could change by natural conditions like air composition, not only pollution, just simply because of the regime of winds. So this is why we are not very comfortable with that. But in any case, it's a good classification for the idea to know that every time that we lost something, we are in a worse position. So if we cannot see anything, we have a Wortel scale 9 or 10, that it's the end ends at 9, but there are areas that are worse than Wortel scale 9. What I recommend is to use the measure with the limiting magnitude or the SQM, and take into account that this measure has important uncertainties. I forgot to say here, but if you want to have a look, there is a project. I was involved in that. I'm one of the authors of this project. That it's called Gambons. I will type on the chat. Let me type on the chat. And okay, the chat is here. Okay, the project is called Gambons. The website is something like this. I am typing on the chat too. This is the website, gambons.fqa.ub.edu. This is a project of the University of Barcelona I'm involved in, that we create a natural map of the sky. This means without light pollution. So if you put your location, longitude and latitude and some weather conditions, you get a map of your sky if there was no light in the surrounding. So you can compare with what you have. And if you check the natural sky, you can see in different moments of the year, at different hours of the night, you get variations that are bigger than the difference between Wortel 1 and Wortel 3, for example. Just only for natural effects that are not linked to light pollution, that are just natural sources. And this is why we are a little bit critical with this. In the past, it was very useful, but now we have better things with the use of the numbers of the measurement. And I recommend, if you are curious on that, to check this website and simulate in your site how the natural sky is and compare with the sky that you have. And you will see what happened. And you can identify a little bit your light sources. And in any case, the strategies of protection has to be always to go to get better sky quality. It doesn't matter if we use Wortel scale or SQM value or whatever. The important thing is that the strategies needs to lead to get more pristine conditions and the use of the light just when it's needed, and when and where it's needed.
Thank you so much.
Okay, thank you, Sir Sonic, for your question and for answering it, Dr. Ribas. We also have another question from Jeremy Jamboy. Do you want to ask your question personally?
Okay, thank you. Thank you, Sir Justin. Good evening, Dr. Ribas. My name is Jeremy Jamboy po, and I am currently a student of Master's of Science in Astronomy major in Astrophysics. So my question right now, since light pollution is what I'm planning to take a look at when it comes to my research for with astrophysics with connection to the private sector. Do you know, or are there future research opportunities or topics or research questions regarding light pollution that are not yet that do not have any research yet right now?
Yes, in fact, I think that light pollution is now probably the topic with more open questions in astronomy. But we are not so many people in astronomy working on that. This is the reason that we have still more open questions, because it was light pollution research and night sky quality research was something that was done in the past in parallel with the astronomical observatories to check the quality of the astronomical observatories, and not from the ecological and global perspective. And this change of vision, it has been done in the last 7 or 8 years, so it's very recent. I remember that 10 years ago, all the international meetings and conference on light pollution were from the activism point of view, not from the research point of view. And since 2013 to now, we have at least 2 or 3 conferences per year that, well, not per year, every 2 years, some of them, that are focused on research on light pollution and artificial light at night. So we discovered, thanks to this, that there is a field of research, very important, that combines, it's a multidisciplinary, combines from astronomy measurements, combined from satellite imagery, combined with impact on health and natural environment, and we have a lot of gaps of knowledge at this moment. So the main problem that we have on research on light pollution is that it's quite complicated to get grants or research projects on it. Why? Because it's a multidisciplinary, and sometimes in many countries, especially in the European Union, the research plans were very classified, too much classified. Astronomy, biology, health, chemistry, whatever you want. But there is not a good call for projects that are multidisciplinary. And light pollution is not, studies are not an astronomical project. We cannot compete with exoplanets detection, for example. Or in health, we cannot compete with cancer. But we can compete in our multidisciplinary. And for the moment, it's quite complicated to get projects and to get grants for students, for example. And this is one of the difficulties that we have. Just 2 months ago, one PhD student was my first PhD student, did a PhD on modeling light pollution. This is the modeling the light propagation and how it affects the propagation of light from the cities to the sky. And it was a wonderful PhD. And we were lucky that a research team in Canada that is working on the same offered him a postdoctoral position for 1 or 2 years. And now he's just traveling to Canada now. But it's quite difficult because of this multidisciplinary that it's very nice. It sometimes gets complicated to get funds. From the other side, because we are linked to environment, it's normal that in the near future we'll have more opportunities. And there is a lot of things to do because we still don't know exactly how we can, from the instrumental point of view, we are still not sure about if the instruments have some kind of aging effects, for example, and we need to recalibrate it. We don't know if exactly how the propagation of light is done in some air conditions. The effect of the aerosols, for example, is not studied. This is from the physics point of view. I'm a physicist, astrophysicist, and this is just only from my point of view. But from health, from biology, they are the same. They have a lot of gaps of knowledge. So it's a research topic that will expand for sure in the next year. As I said before, 10 years ago, there was no meetings on research on light pollution. This year, we organized the Artificial Light at Night Conference, ALAN 2021. Next one will be in Canada in 2023. We organized it here in my city, in Lleida, but unfortunately it was an hybrid conference due to the pandemic situation. And we were 200 persons. So now we are more than 200 researchers all around the world working on the different topics of light at night. And 10 years ago, there was no meetings. So this means that this is an expanding research field.
I see. Thank you for that detailed answer, sir. I guess the real challenge here for the scientists and for the government is that, you know, the awareness of the public regarding the effects of light pollution. And I think the private sector will be able to, you know, have a major role in letting the people know regarding this one. With regards to that, sir, so which country is now leading in terms of reducing light pollution, sir? Is there any particular country or organization?
Well, from the organization point of view, I think there are two leading organizations promoting good policies. This is the case of International Dark Sky Association, based on the United States, but operating worldwide. And there is the Starlight Foundation, that is based in Canary Island and operating almost worldwide, but mainly centered in Spanish-speaking countries. But these are, they have the two defining good policies and strategies. And then there is the, from the country's point of view, I think that we cannot identify one country that is doing things better, but we have a general trend in the case of European Union at the moment that protected areas are taking into account the problem of light pollution, and this means that the surrounding areas needs to take into account light pollution, and this was not happening 20 years ago or 15 years ago. So these are moving to a better lighting systems more or less in all Europe. Around legislation, for example, now we are in a critical moment in Spain with the new regulation that will have good things, like they will not allow white blue LEDs, but they are allowing, for example, to illuminate areas that are too close to natural environment. So what is not good. We are now dealing with the government. The Spanish research community is dealing with the government about this new regulation because we are not completely agree. There are things that are okay, there are things that are not okay. If we got a good regulation, probably we will go on the right way. In the case of my region in Catalonia, we have done very good things in the protected areas like Montsec, but not very good things in big cities like Barcelona, for example. Sorry. So it depends more on the environment strategies, if they exist, if they take into account the light pollution problem, than not if we are in one country or another. But in the case of Europe, things are moving. In the case of the United States, IDA has pressed so much and they are moving a little bit. And I think that is important because at the end, as we say, normally North America and Europe are the reference for the rest of the world. Normally for the bad things, but in this time we can be a reference in something good. It will be a great idea because I think that from Europe and North America only bad ideas appear. If for one time we have a good idea and we can export to all around the world, will be nice. And I think that it's important. And if we have to define a place where the strategies have been running for many years, we can go to Canary Islands in Spain, that they have protecting the observatories, and Chile. Chile has a historical protection, and now they will have a law, but in the past there were just some strategies that to protect the astronomical observatories of Chile. So Chile and Canarias probably they have the more consolidated strategies in the world, getting better results from the protection of astronomical places. And in the case, Catalonia is trying to do the same to protect Montsec, but we started later than Chile or Canarias. We started 20 years ago, and Chile and Canarias started 30 or 40 years ago to protect the sky.
I see. Okay. Can I also ask one more question? Sorry, sir. If it's okay? What if the light pollution is really, let's say, really high to the point that it's really hard to stop it? If there would be a future geomagnetic storm, would it have a fatal effect on Earth?
Well, I'm not expert on that, but let me say that if we have what I'm always saying is what happens if we have a complete blackout for some reason, we will discover from one moment to another that the sky is full of stars. So it's a little bit of philosophy. So I don't know if what could happen in this case from the engineering point of view. What I have to say is that, for example, when we do measurements by satellite, we have many problems to analyze the data from the polar areas because of the auroras. So from the light from aurora. So in case of geomagnetic storm coming from the activities from sun activity, probably will have problems to do measurements because it will be affected by the the atmospheric lights like auroras. So this will be happens for sure. But I don't know if we could have any other effect on this, and I'm not sure.
Okay, thank you so much, Dr. Ribas, for answering my questions.
You're welcome.
Okay, thank you, Miss Jeremy. Next question is from Miss Mary Crystalline Ararakap.
Am I loud and clear?
Yes po.
Thank you. Good afternoon, everyone, and good evening to Dr. Rivers. First of all, before I ask my question, I would like to give thanks on this structural and very informative presentation. I am Mary Cristina Ararakap and currently a master's degree student of environmental science in the University of the East. By the way, my bachelor's degree is BS Astronomy Technology. Currently, we are my advisor and I are watching your webinar. So, our question is the following. Uh, because we are intended to make a thesis, a proposal thesis about the morphological effects of light pollution in the I'm sorry, about the effects of the light pollution in the morphological effects of butterflies in the butterfly sanctuary of Pasig City. Manila is the capital city of the Philippines, and light pollution, as you have shown in your slide, it is quite rampant in our area. So, my question is, are there any uh, data gathering procedure, because BIRIRS was our only means by now for detecting the presence of the light pollution and for mapping it out for our data gathering procedure. Is there anything that you can suggest that we can use for our data gathering procedure? That's all. Thank you, sir.
Okay. Nice question. I think maybe you have typed also the question on the, because I saw on the chat something about the butterfly. And
Actually, that's me.
So let me say that it's very important to do these studies, because we need more studies showing how the lights are affecting a natural environment. So do it, please. And then the second thing that I want to say on this is how related to your question about the getting data. So from the, I will maybe I have not type my email. I will type my email here, just in case that you need to contact me, any of you with a question. I will try to answer everybody.
That will be great. That will be
But
great.
I'll because in the past, and not so far, not many years ago, we started a project that was called Pyrenees La Nuit. So this study the Pyrenees mountain range when we are in the southern of the Pyrenees. And this is in the case of Pyrenees, they have done a study with butterflies. And what they do is to create some boxes that they will install in the different kind of lights that they have in different villages to discover what kind of species are being attracted by one light or the other, and what kind of lights are attracting more or less butterflies. So this can give an idea of the better strategy of lighting for the future. If one kind of light is not attracting butterflies, will be safe for this species to use this than not the other. That's one of the strategies. And the other thing was to combine this with, but it was not completely done in the project at the end, unfortunately, to combine this with measurements from the quality of the night sky, so the darkness. So as you say, there is the satellite images like BIRS images, and but BIRS is only one picture per night, and it works, but it's satellite measurement. And sometimes what is better is to have some kind of ground measurements, because our butterflies that you plan to study, the butterflies will not observe the Earth from the satellite. They will live at low altitude inside, under the trees, on an environment, on an area where it's the situation is similar to our position, so more ground-based than not satellite-based. But it's quite complicated to do ground-based measurements. You need to buy and install devices, and sometimes this is expensive, and sometimes it's not easy to do. But I recommend, if you have the chance to get a project that allow you to do some ground measurements in parallel with satellite, will be quite good. Because if you discover that some butterflies are going to one place and not to another, maybe it's because one area is darker than the other. This satellite could not give you enough detail. And using some SQM devices or taking these all sky pictures could help you to get the data. Probably the cheapest is the SQM devices, that they could cost starting from $100 US dollars up to 300 if you put some housing and some electronics there. But to have it to measure different points when you are doing the study will help you to take into account the parameter of light better, because you will have the information from the ground. This is the feeling that we have are more similar to the feeling that the butterfly will have. Of course, the best option could be the all-sky cameras, but all-sky cameras are extremely expensive, and you need to calibrate it, and one calibrated camera could cost around $2,000. It's not so simple as getting satellite data, and it's more expensive. But this the one that was used, for example, recently in Australia to analyze the effects on careta on sea turtles, taking pictures on the offshore at different altitudes, at the different orientations, to analyze how is the light coming from the ground, from the populated area to the sea. And this could be done also in your case, not with the sea, because you are analyzing probably in inlands, but to know where are the lights coming in that site. And this is only possible to do with all-sky imagery. But I say all-sky imagery is something that it's a little bit more expensive, because, for example, we have 2 cameras for this, and each one was around 2,000 euros, with the $2,000, because we have to calibrate it on a lab, and this is quite expensive. We hope that in the future we can use any camera with this open source software that is under development, but we don't know it would happen in 3 months or in 1 year. But in this case, with any photographic camera with a fisheye lens that will give you the whole sky, you can process the data if you store the data with a raw format, not with JPG or PNG, just with the raw format of the camera. But this software is still not ready. It's quite complicated, and it's an open source, and it's people working on it. But I hope that we will have it. But for the moment, the best solution is just to spend these 2,000 euros in one all-sky camera calibrated, and you will get the software to process the data, and you will get the information without being an astronomer to analyze the data. But it's expensive. I recommend ground measurements, but I know that ground means extra devices and means a more expensive project.
Follow-up question, sir. Are there any open source website or organizations that are also doing this, where we can collaborate this thesis proposal?
Yes, I think that you can check contacts from the Loss of the Night network. It was an European project, but now it's worldwide open, because now it's no funds there. But this is, let me try to find and I will put it here to somebody. And maybe the good option could be contact this project. I was part of this project. And if they can help to find people that are working on butterflies, and they have it, sure. If not, there is also a way. This is the European funded project that ended in 2016 or 2017, I don't remember. And there were working groups, campaigns, and so on. And I hope there is a contact somewhere. Let's see if there is a contact in some way. Yes, there is a contact. And explain that you are doing this, and you want to find people, and maybe they will join you to there is a Loss of the Night network mailing list, where people from all the fields of light pollution studies meet together in a mailing list, and if there is any project, any idea, any question, people ask, people answer, and it's quite active to answer other questions. So I think that it could be a good option to contact the LON network. And I will also put here but I think it is only in Spanish, the web page of Pirineus La Nuit project. This European project that I was involved too. We do some studies with butterflies, and but everything is in Spanish, I think. But it's I think there are some actions linked to, or will appear very soon, some summaries about the measurements on butterflies. But we will check. And about the conference, there is the main conference on artificial light at night, just for anybody that could be interested. I will put the. Sorry, my dog is not very happy today. So this is the Artificial Light at Night web page. This Artificial Light at Night is the conference that every 2 years takes place, and you can find also on the schedule some presentations that could be linked. The presentations are not available for the moment, but you can find some authors that could do work similar to you, and maybe you can get the contact for them. So this is useful for any one of you. Artificial Light at Night was the conference, the worldwide conference that every 2 years happens. This one was online because of the pandemic, but has to be done here in my region. But next time will be in Calgary, in Canada, in 2023, and it's every 2 years it change the continent. And there, with the schedule, you can get information about what the people are doing. There are also the book of abstracts, so with the summary of the presentations of this conference. This could be a good place to look for other teams that are doing similar things. So check this artificiallightatnight.org or costlone.eu. This is the European project, and contact the European project that is now just a network. It's not an European project, and so they can help to find people that work with butterflies, and for sure they will join you on the mailing list, and you can interact with other people of the Lone network.
Oh my God, thank you so much, sir. That's a big help for me as a student and also to my thesis advisor, because as mentioned earlier, the light pollution and also the ecological effects to urban ecology is not popular field of study in the Philippines. So thank you very much, sir. We appreciate this. In behalf of my advisor, who is beside me, doesn't want to show up. Thank you.
Okay, next.
You're welcome, and I will just add here my email that normally I put it on the last slide and I forget it. Normally I add the email on the last slide, so people can contact me. I'm not very fast answering all the emails, but if you have any question on all the people that are here present, I will try to answer or to orientate to the right person that can answer.
Thank you, sir. Next question is from PAGASA, Pampanga River Flood Forecasting Weather Center. Question is, if light pollution is sorry. So the question was, does light pollution somehow have an negative effect in weather or climate?
What's the last word? Sorry, can you repeat the final part of the question? Is any effect on, and I missed the words.
Does light pollution somehow have a negative effect in weather or climate?
Okay, weather climate. Well, directly not, but we know that in any case we are wasting energy, and if we are wasting energy, we are contributing to the global change. So this is the link that we can have with weather, and what happens is that weather is on the opposite side. Different weather conditions can amplify the effect of light pollution. So light pollution is not changing weather except contributing to the global change with the waste of energy, but weather and atmospheric conditions can modify the effect of light pollution, increasing or decreasing some of the impact of light pollution.
Thank you, Dr. Ribas. So, another question is from Sir Uriel Tumanan. Is IAU allowed to make regulations or limitations or submit laws to government agencies regarding the regulation of light pollution in communities?
Mainly the regulations have to be done by countries, or in the case here in Spain, we can have regulations from the European Union. But IAU is just an NGO joining all the astronomers community, professional astronomers community, and can contribute to do pressure to the governments like they are doing now. There is a commission on the protection of dark skies. The same it happens with the IDA, the International Dark Sky Association, that they are doing pressure, but they are NGOs, so they cannot do regulation, but they can help us to prepare regulations in the countries, or they can help us in the pressure strategy especially with the big governments like European Union, like the United States, or like any other government that are ready to listen the scientific community.
Thank you again. So next question is from Marion Kakatian. Given that light is also becoming a pollution, what is your take on the case of researchers that is using light to revolutionize agriculture by accelerating growth rate of a flora and at the same time prevents certain harmful insects?
Yes, this is there is an historical use of light for growing plants or for fishery. On the boats, they put some lights to attract fishes. This is happens as far as the story of lighting. Let me say that I cannot say don't do it, because probably people that are in some moments, you need to use these strategies to get food to survive, or to get food to sell it and have good living conditions. And say forbid this forever could be a problem for many families around the world, because they don't have the way to earn money. So I cannot be drastic in this case. But what I say is that in the case of greenhouses illuminated, I have to say that the nice thing is that they have to think that to try to use the lights as focused as possible, to not send the lights outside the greenhouses, because these lights coming outside from greenhouses will attract all the insects or all the species around outside the greenhouses to go in. So of course there will be an effect, an ecological effect inside, but at least not expand this effect outside of the greenhouses. This is all what can, in an ideal world, these things have not to be done, but we are not living in an ideal world, and people need to survive. So let's just give some recommendations and not prohibitions.
Thank you for that answer, Dr. Ribas. So, before we proceed to the next question, some participants are asking if you are willing to share your presentation with us.
Yes, I will. I probably have to remove some scientific results, not the text, but some graphs, because they are published from journals, and it's possible to use it for a presentation, but depending of possible future use, could be a problem for me or for the person that uses it. So I will prepare a clean version in the next days, probably next week, and we can, from the organization, please contact me to not forget to do it, and I will prepare a PDF version with removing some of the pictures that could have restrictions, at least to keep the text and the basic graphs information, to keep the essence of the talk will be there, but some pictures for copyright reasons I cannot distribute it.
Okay, thank you for that. And then for our next question, we would like to ask Mr. Valgerald Garrido, if he wants to ask his question personally.
Buenas tardes, buenas noches, Sir Ribas.
I have to say that here is in the morning. Somebody is saying good evening, but here is in the morning. It's 10 a.m. Well, 11 a.m. So it's good morning that I have not corrected before, and I forgot to say that here is in the morning.
Bien. Me llamo Valgerald Garrido. So I'm a student of MS Geomatics Engineering from the University of the Philippines. So my pregunta is, you showed a light pollution map showing uh, in this how do you call that, concentration of light pollution in a certain metropolitan area. So may I ask what kind of data set used on that specific map? Like, I do know it is a output based from different bands that use from the satellite images, but I want to know what kind of satellite you use for that. Since I just know Landsat, Sentinels, and other satellite platforms, but I haven't seen the specific satellite used for light pollution. Thank you.
I have added here on the chat the last web page that I put on my presentation, lightpollutionmap.info. On this web page, there is a lot of AdWords on this web page, but after that, you get the map, and these maps are coming from two main sources. One is the BIRS. This is the satellite data coming from BIRS is the most common that we use, because one of the problems that we have on nighttime observing is that there is no satellites taking pictures during the night. They are more prepared for daily imagery and not for night imagery. And BIRS NPP is it's part of the name of the satellite is yes, Suomi NPP. I just remember Suomi NPP, and it works with they have the day-night band and the visible infrared imagery. This is the BIRS. I will type here. Let me type. It's the Suomi NPP, and it's day-night band DNB, and there is also the BIRS detector. This is the one that is used on this on these maps, and in the case of the wall atlas, in this website that I sent, is also the wall atlas. Wall atlas is a combination of this satellite imagery with ground-based information. So the wall atlas is a little bit more accurate because it combines BIRS data with the ground-based, so it's more realistic probably. But mainly this is a satellite that we can use for the moment. It's a Suomi MPP with the day-night band BIRS detector, because it's the one that is really working at nighttime with good results. And there is a second option that is very promising, that is the International Space Station photographies. So ISS astronauts take pictures by random sometimes, and can provide us information that could be useful for the lighting inventories or for the effects of light pollution. But they are not on demand. They are not worldwide. They take pictures of what they like it in some moment, or things that are catching the attention of them when they are on the ISS during nighttime. So this is not systematic as this lightpollutionmap.info webpage that have stored the images worldwide. So if you check this light pollution map, after you have removed all the add-ons, that it's simply terrible, but they need to survive because it's an initiative of a private initiative of one amateur astronomer and activist against light pollution. He is trying to work on it and needs some money, and they put some ads to get money. But in this way, you will get many recent information with Wall Atlas or with the last piece data, and you can check in your country how things are changing from one year to another, and it could be something really interesting to check.
Yes, thank you very much.
So due to the time constraints, we will be entertaining the last two questions. So one is from Sir Donald Vega, who raised his hand. Sir? Sir Donald, you can now address your question to Dr. Ribas. So I guess Sir was not here. So for the last question from Sir Julius Katabay of UP Diliman, he says, thank you for this well-structured and informative webinar, Dr. Riba. So his question, artificial satellites in Earth's orbit are a new form of light pollution, and many companies plan to launch tens of thousands of artificial satellites, mega constellation of artificial satellites, and that may affect our view in the night sky. As part of the IAU, what is your insights or opinion about this matter? Thank you, Adasta.
I love this question. I thought that I will end the webinar without it, but no, at the end we got it. Yes, this is a big problem. It's a big issue for light pollution, not from the ecological point of view, because the amount of light is not enough for ecological point of view, but for the astronomical point of view. We have a new problem that is called, for the moment, Starlink. That is the constellation of satellites that is running, but we'll have more in the next year for sure. Difficult to stop this because it's very difficult to stop technology. But we have to say that it's a big problem because some studies showed that when all these constellations will be running, just with the small diffuse light that they reflect, there will be no pristine sky anywhere on the Earth. Because when we have thousands of these, they will have a small amount of light. They only bright so much the first days. They will go up and reach a position where they are not visible at naked eye. But they are there, and they are reflecting light coming from the sun. And with thousands of them, in any part of the world, we'll have some, let's say, remnant light that will not be visible to our eyes, that will increase the background of the sky above what AU is considering pristine sky. So this means that this satellite could end with the pristine skies in places like Atacama Desert, for example, or in Central Australia, or in Namibia, or in Hawaii, or in La Palma, in Canary Island, because it's a global effect in this case. So what is doing now? There is a commission on the AAU, and there is a meeting next week, starting next week, on that was scheduled to be in La Palma Island, but now with the volcano, I don't know if we will do it in La Palma. In La Palma, they have a volcano eruption that is not very common. It's a volcanic island, but it's not very common here to have eruptions. And now we don't know if we can do the meeting in person. And this is a conference with organized by the United Nations Office for Outer Space Affairs, and AU is involved there. And there will be a kind of recommendations at the end of what United Nations have to do with this, trying to get not stopping the progress, but to do it as less problematic as possible for the astronomy. But it's quite complicated. Let me say in any case that Elon Musk from SpaceX project, that was a Starlink project, he was quite sensitive with the community of astronomers. In fact, he's physicist, and assist to some meeting of the American Astronomical Society. And after that meeting, he decided to darken the satellites a little bit. So now the satellites are not visible naked eye when they are reached the right position. So this was an important step. So this means that there is some sensitivity to try to no effect. But in any case, the effect on professional astronomy is still there. Because professional astronomer means telescope and cameras that reach fainter values, and this is not enough to darken a little bit the satellite. So they are not in a, let's say, in a war, in a shock between the two sides. There is dialogue, but it's quite complicated to find a solution because industry wants to put satellites for communications or for any other purpose, and this means this kind of light pollution affecting professional and amateur astronomers that will take long exposure pictures or doing research with telescope. It's a problem, I think that it's we are a little bit crazy putting thousands of satellites on the atmosphere. We don't need it probably, but I know that it's difficult to stop the evolution. So I don't know if there are more questions or we are out of time probably. I don't know.
Yes. So thank you everyone for all the questions, and we would like to apologize for some questions that were not addressed due to time constraints. And again, thank you again, Dr. Ribas, for answering the questions and for the great presentation. It was a pleasure being with you today.
So now we will proceed with the awarding of the Certificate of Appreciation to our IAU Astronomer, Dr. Salvador J. Ribas. So the certificate reads, Department of Science and Technology, Philippine Atmospheric, Geophysical, and Astronomical Services Administration, Certificate of Appreciation is awarded to Salvador J. Ribas, PhD, in grateful recognition for sharing his expertise during the IAU-OAO Meet the IAU Astronomer program, with the webinar entitled Light Pollution and Its Multidisciplinary Effects, held via Google Meet on 24 September 2021, given this 24th day of September 2021. Signed, Vicente B. Malano, PhD, PAGASA Administrator. Thank you for sharing your knowledge with us, Dr. Ribas.
Thank you very much for being here to organize this event. It's always a pleasure to share content using these new technologies that allowed me to talk with you, that we are in the other side of the world, that in other ways not possible without the technology, and it's a good opportunity to meet and to know your problems about this topic, and you can know a little bit more about the problem and what we are doing in the scientific community. So thanks to be here. Thanks for the wonderful organization. I'm hoping to meet you soon in another event.
Thank you again, Dr. Ribas. So to our participants, you can now access the link to the evaluation form sent in the chat box. Please accomplish the form by 7 p.m. and the certificate of attendance will be emailed to you shortly. Again, thank you for sharing your time with us.
So at this junction, we will hear a closing message from the Chief of the Research and Development and Training Division, Dr. Nathaniel T. Servan.
A very pleasant afternoon to all of you, and good morning to Dr. Ribas. At this very moment, we have reached the end of our event for today. A highly specialized and unique webinar offered by the International Astronomical Union, or IAU. We in the R&D and Training Division of PAGASA, particularly the staff of the Space Sciences and Astronomy section, headed by Ms. Rosario Ramos, who organized this event, would like to express our appreciation to each and everyone who took the time and effort to participate in this virtual activity. Participants, which include some PAGASA employees, as well as teachers, undergraduate students, and astronomical organization members from different areas in the country. Of course, we express our appreciation to the International Astronomical Union for sponsoring a series of webinars on various topics for astronomers, teachers, and students. We are grateful to our resource person for today's event, Dr. Salvador J. Ribas, who is affiliated with the Parc Astronòmic Montsec of Spain, for his wholehearted support by eagerly sharing his knowledge on the topic presented. For astronomer enthusiasts who are here today, for sure they are very delighted with the discussions about light pollution and how it significantly affects the quality of observational observation, especially in areas like Metro Manila, a big city, where a true dark sky is difficult to find. Thus, we cannot truly appreciate the beauty of the night sky. And other adverse effects of light pollution to humans and animals, as discussed earlier. The webinar is indeed very enlightening. Muchas gracias, Dr. Ribas, for your lecture today. And of course, lastly, I would like to also express our thanks to the support of the PAGASA management headed by our administrator, Dr. Vicente Malano, and Deputy Administrator for R&D, Dr. Esperanza Kayanan, who delivered a welcome messages earlier. Thank you, and wishing you a pleasant and safe weekend to everyone.
Thank you, Dr. Servando. So to wrap things up, we would like to request everyone to turn on their cameras for our group photo. Okay, don't forget to wear your biggest smile. Well done. One, two, three. We would also like to give everyone a minute or a few seconds to please open your microphones and say hi or thank you to our speaker, Dr. Ribas, who shared this expertise with us today. Thank you, Dr. Ribas.
Thank you.
Thank you so much.
Thank you, Toriba.
Hi, Ador. Hi, Alan.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you
Thank you po sa lahat. Hi, PB.
Hello, sir.
Salamat po.
Thank you to Pag-asa.
Gracias,
Hi, Alan.
Gracias.
Salamat po.
So, before we end this program, we would like to invite everyone to join us again next week on our celebration of the 100 Hours of Astronomy with special partnership with the International Astronomical Union-Office for Astronomy Outreach. We will be having Mr. Timothy James D. Makati of the USC to discuss ethno-astronomy in the Philippines. The registration link is posted in the chat box, and we would be delighted to see you again on our next webinar.
So this concludes our webinar. Thank you all for attending. Again, the evaluation link is also in the chat box.
Thank
And
you so
on behalf
much.
on behalf of PAGASA and Dr. Ribas, thank you for joining us today. Enjoy the rest of the week and have a great day. We will see you next time.
Happy
Happy weekend.
Thank you po. Ay, ano ba to? Thank you.
Daghang salamat.
Upload po ng picture.
Gracias.
Maraming salamat.
Thank you, everyone.
Good afternoon.
Salamat kayo. po.
Sige, Archie. Thank you, Dr. Ribas.
Thank you, Dr. Ribas.
Thank you po.
Well, Dr. Telgay mentioned of the memorandum